Welcome to this lecture. In this lecture, we are going to talking about the array in C++. So, an array is a collection of data that holds fixed number of values of same type. For example, if you want to store mark of 100 student or 50 student, you can create an array of 50 student, like you just write float, or you just write integer marks, and this is a bracket to declare an array, and you just write 100 student of array right here. The size and the type of array cannot be changed after the declaration. Remember that. As I just told you that we have two types of array, which is one-dimensional array and the multi-dimensional array. In multi-dimensional array, we have the 2D array and 3D array. Now, how to declare an array right here? First of all, you just write data type, then array name, and then you just write array size, that how much size you just need to declare an array. So this is a simple declaration of an array right here. So here we just declare the array like integer and marks, which is 100. So simply we just declare the array of 100 students, means it hold 100 integer values. So the element of an array, like you can access element of array by index, mean by indexed. Suppose you declare an array mark, like declare array marks like this one. So the first element is marks in 0. So it will start from the first element to 0 and it will go up to 99. Okay, and then so on, how much array you want to create. So how the array index will check? You just write mark 0, and this is the index number 0, and then you just write marks 1, and then here the index number 1. So it will go like this stage, so because this is the single dimensional array. Some of the key notes of the array means when you are just declaring the array, so keep in the mind that array has 0 as the first index, not 1, like this example is you can see here. So if the size of an array is n, to access the last element n-1 index is used, as you can see here, like this one. Suppose the starting address of mark 0 is like any address, like mark 0 address is here, like we have the address 2120D. Okay, so this is the address of that one. Then the next address of this mark 1 will be 2124D. Okay, the address of 2n will be the 4D, and up to so on, and it will go after 2128D. So simply it's take the 4 bytes. Okay, and sorry, it is an integer, so it's take 2 or 4 bytes. You can see here integer is take 2 or 4 byte, and if it is short, so it will take 2 bytes, and if it is float, so it is also take 4 byte. So the address of that array will go like this conditions. Okay, so how to initialize an array? It is possible to initialize an array during the duration declaration. So you just simply write int marks, and here marks of 5 student, and which is equal to, so you just declare the marks of that, like 19, 15, 20, 13, and 40. So these are the marks of these 5 students. So you just declare with these curly brackets. Okay, so let's just see the example of that array. So here I just simply write hash include. So I think you just understand what I just said about the arrays. So if you not understand, please let me know. and then using namespace, and we just go to the integer main function. Okay, now here I just define the integer marks, the marks of 3 students right here. Then I just take float average, because we just always take the average in the float, because averages always come in the points, so that's why I just take float right here. And cout, which is enter marks of first student, and then I just write end line right here, cn, and here I just write marks on index number 0. As I just told you that array always starts from the indexed 0. Now cout marks of second student, and here the array indexed is 1. Then mark of third student, and the array here is 2. So it will take the user input of array like 2. Now here I just create a data type of float, means I just take the integer which is average, so I just write average here, and average is a data type of float which is equal to, and here I just write bracket, then mark number 0, then I just write plus, then marks number 1, then I just write plus, then marks number 2, and this value divided by 3.0. So this is a simple formula of average. So cout, and the cout right here is, I just write average marks. Okay, and then here I just write average, so it will print the average right here, and then end line, and close this code right here. Now return 0. So now I just run this code, and this is the average right here. Cout. Okay, so this is cout, and now I just run this code. So 12, 13, 14, and the average mark here is 13. So as you can see here, I just create the size of an array which is 3D. You can see here first student, second student, and third student. Then I just create an integer, I just create a variable which is the float for finding the average. Then I just create the user input, and then for mark number 0, 1, 2, so this is index number 0, index number 1, and index number 2. Okay, then I just create a formula to find the average. So average is equal to marks, so mark 0, 1, 2, 3, and then cout simply the average marks and the average. So output is average marks are 13. So let's just explain this example again. So 2 points should be kept in mind. The average value should be the type of float, because the average of integers can be float also. Secondly, while taking out the average, sum of the numbers would be divided by 3.0, not 3. Okay, so this is divided by 3.0, not 3. Otherwise you will get the average value as an integer, not float. So that's why I just write 3.0 here. Okay, so this is a simple example in array. If you find any of the problem regarding to these arrays, please let me know. Thanks for watching this lecture. Welcome to this lecture, and in this lecture we are working with one another example to make clear your concept in arrays. So here I just take a start with this example. So here I just write hash include and iostream, and then using namespace std. Okay, now integer main. So this example I just create array with for loop. So here I just write integer n, and this is integer n, the array name, and the index size here is 10. So declaring an array as the array of 10 integers. Now I and j. So integer I and j here. Now here I just initializing the element of array n. So for loop, so I which is equal to 0, I which is less than 10, and I plus plus. Okay. Now cout here is I just write enter value of n. Okay, and then here I just write I, and then here I just write j. So not j, it's a bracket what I just create here, and this is the bracket. So end line and close this code here, and then cin which is n and the array index which is I. Okay, close this code, and now here I just write for loop again for printing the value of element of an array with the help of this for loop. So j which is equal to 0, and then j which is less than 10, and j plus plus. Now here I just write cout, and the cout here is I just write n, and then here I just write j and close this bracket. Okay, now n which is the index of j, so it will print the index of j right here, and then end line. Okay, now I just write here return 0. Okay, so now just check the output for this code, and here yes, now I just check again. So number of n digits in means number of enter the value of n which is 0, and the value will be between in 10. So here I just write 2. So enter the value of n which is 1, 2, and 3, 6, 5, 4, 9, 9, 52, and 10. So you can see here it's print every indexed array. So in this example, we just to make you similar with using loop within array, because you can be doing this many times later. The code is simple, like I and j start from 0, because the index of an array start from 0 and goes up to 9 here. You can see here in this start from 0 and goes up to 9 here for the elements of 10. So I and j goes up to 9 and not 10. So I is less than 10, and here you just see j, I is also less than 10 and j is also less than 10 right here. So in this code, n and index of I right here, so you can see here, which is our user input, will be take 10 inputs. I just take 10 inputs right here. For there are two for loops in this example, as you can see here, for loop and for loop. So in first for loop, we are taking the value of the different elements of the array from the user one by one. And in the second for loop, we are just printing the value. You can see here we just printing the value of this j right here and this loop here. Okay, let's go to the first loop. So in the first iteration, the value of I is 0, and so n of I you can see here, and thus by writing cin means writing cin right here, so the user will ask to enter the value of index 0. Similarly, in the second iteration, and the value of I will be 1. So n of I will be the n of 1 when you just enter the 1 right here. You can see here this is the n of 1. So array allocates the continuous memory. Thus, if the address of the first element of an array of integer is x, then the address of the second element will be x plus 4. 4 is the size of one integer, and the third will be x plus 4 plus 4, and so on. This means that the memories of all elements of an array are allocated together and are continuous. So this is a simple example of an array in C++. If you find any of the problem regarding to this lecture and you just not understand anything in this lecture, please let me know. Thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to learn about the passing the whole array in a function. In C++ we can pass an element of an array or the full array as an argument to a function. Let's just see how this works. So here I just write hash include input out stream, then using namespace std, then integer main, and here I just write integer n, and then which is equal to, here I just write the value which is 20, 30, 40, 50, 60, 70, 80, 90. Okay, and then I just go to declare a function, so void and display. So this is our function name, and here I just pass the parameters which is int a. Okay, now here I just write cout and cout which is a, and then end line. Okay, so it will print the a right here. Now here I just call a function, so display, and the display here is n of 2. Okay, and then close this code right here, and then I just write return 0. Okay, and close with the brackets, and yes, semicolon. Okay, and semicolon. Okay, now I just run this code, and as you can see here, the array value on the index number 2 here is 40. So 0, 1 and 2. So we can also pass the whole array to a function by passing the array name as an argument. Yes, the trick is that we will pass the address of an array, that is the address of the first element of an array. Thus, by having the pointer of the first element, and we get the entire array as we done in this example. You can see here. Okay, so this is a simple example of the array passing the whole function. Okay, so as you can see here in this code, I just simply define a function to outside the main body, and then integer a, this is our parameter right here, so I just simply print the value of a. Okay, now here I just call this function and display n, and I just ask that print the array on the index number 2 with the help of this function. Okay, so this is a simple example of the functions and the array, and if you find any of the problem regarding this lecture, please let me know. Thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the multi-dimensional array in C++. The simplest form of the multi-dimensional array is two-dimensional. It's two-dimensional array. Two-dimensional array is an instance, a list of an one-dimensional array. Two-dimensional arrays are generally known as the matrix, which is consist of the rows and the columns. Before going into its applications, let's first see how to declare and initialize the 2D array. As you can see here, like on the screen, we have the rows and the columns. So this is a simple simple syntax, as you can see here, how this 2D arrays work. So these are our rows, the values of the rows, and these are the columns. Okay, so it's work like this one, rows and the columns. Let's just see the initialization of the 2D array. Same as a 1D array. we can assign the value to the two-dimensional array in two ways. So in first method, we assign the value to the element of the array. If no value is assigned to an array, any element, then its value is assigned 0 by default. Suppose we declare a two-dimensional array like here, a which is 2 and then 2. Okay, so this is simple syntax of the two-dimensional array. Okay, and it's also look at as at matrix. Then the second method is, so this is our first method, then second method is integer a 2 3, and which is equal to, I just assign this value 1 3 2 2 4 5 6 and up to so on as I just want to give any of the value right here. Okay, here the value of a2 and the a3 is 1, and the value of 0 index here is 1, the value of 2 index here is 32, and up to so on. While assigning the value to an array at the time of the declaration, there is no need to give the dimension in one-dimensional array, but in 2D array we need to give at least second dimension. Okay, let's just see how this array works, and let's just see the application of this array. So this program is, suppose we have 3 students in each studying 2 subjects, means subject number 1 and subject number 2, and we have to display the mark in the both of the subject of 3 students. Let's just see this type of program. Hash include rstream using namespace std, then integer main here. Okay, now here I just write float is a data type here, and the marks, then 3 and 2. Okay, there is 3 students and the 2 subjects. Okay, now integer I and integer j. So for loop here is I which is equal to 0, I which is less than 3, and I plus plus. Simple syntax of the for loop. Then cout, which is enter marks of a student, and here I just write I plus 1, and then end line. Okay, so this is the input of the marks from the user. Okay, and then here I just write for loop again for the iterations of j which is equal to 0, j which is less than or 0. These are the subjects right here, and then j plus plus. Okay, now here I just write cout, and the cout here is I just write subject. Okay, and then j plus 1 and end line. Now here I just write cin to input the subject, and then marks, input the marks here, and then I, and then j. Okay, now here I just print the mark of the student with the help of for loop again. So I just take for loop again, and then here I just write I which is equal to 0, I which is less than 3, and I plus plus. Okay, now cout here is I just write marks of student, and then I just write I plus 1. Okay, and then end line. Now just go to the for loop again, and for loop j which is equal to 0, and then j which is less than 2, and j plus plus. Now cout here is I just write subject, then j plus 1, and here I just write colon sign for simply the string output here, and then marks, which will print I and j. Okay, and then end line. Now I just write that return 0. Okay, so in this example, finally we define our array consisting of 3 rows and 2 columns as the value of or the data types of float, which is mark 3 and 2. Here element in the array will contain the marks of 3 students in the 2 subject as like student number 1, 2, 3. Let's just check the output and then discuss this code. And float, and here miss this sign, and miss this sign here too. And you can see here mark of number 1 subject, so 20, 30 and 40, and then 40. Okay, and 50, 50, and you can see here the marks of that. So let's just discuss these. So in this example, you just see here that the marks of student number 1, student number 2 and student number 3, the 2 subjects right here. Okay, so these are the 3 students and the 2 subjects, so these are the marks of that student and the subjects. Okay, so in the first iteration, the outer of the loop value of I is 0, while the value of I is as 0. When the inner of the loop first iterates, the value of j becomes 0, and thus the marks of I and the j becomes marks 0 and 0 in writing Cn right here. Okay, you can see here. Where is the Cn? Yes, here. Okay, we are discussing this point. So now marks of I and j, we are taking the value of marks here is 0 and 0 at that iterations. After the inner of the loop, again iteration value of j becomes 1, and the mark of I and j becomes 0 and 1 at the value is taken from the user at that stage. Okay, after that the inner of the loop again iterates and the value of j becomes 1, and the marks value of I and j becomes 0 here, as I just told you. Then the outer of the loop iteration for the second time, and the value of I becomes 1, and the whole process will continue like this one. So 1, 2 and 3. Okay, so 0, 1, 2, and this is means after assigning the value to the elements of an array, we are printing the value of the elements of the array in the same way using another for loop inside the for loop. As you can see here, first of all, this loop is simply for taking the user input and then iteration of I plus 1, so it's taking simply the value right here, and then here, and then these for loop are simply giving us the output right here. Okay, so this is a simple example of the 2-dimensional array in C++. If you find any of the problem regarding to this lecture, please let me know, because this 2-dimensional array is very much important in C++, and this is very much using in data structure and algorithm. So that's why it's very important to make your concept right here. So if you not understand any of the thing in this lecture, please let me know. I will explain again and again for you. Thanks for watching.
Welcome to this lecture, and in this lecture we are going to talking about the pointers in C++. Let's just start with the pointers. So a pointer is a variable used to store the address of the memory cell. We can use the pointer to reference this memory cell. Like we have the memory address, which are 1020, 1040 and 1032. Here we have the variable, like we have the variable a, which is equal to 100, and this is our integer right here, and the address of that location here is 1024. So C++ pointers are easy and fun to learn. Some C++ tasks are performed more easily with pointers, and other C++ tasks such as dynamic memory allocation cannot be performed without pointer. So as you know, every variable is a memory location. In every memory location has its address defined, which can be accessed using assumption like AND operator, which donate an address in the memory. Consider add memory like I just go to the next slide, and here you can see the pointer types, which are the pointer in C++ has the integer object, character object, and user defined object like relational numbers. And every pointer has the pointer to pointer integer object like integer, like we have the integer and then static and static. So this is called pointer to pointer integer object. Here just discussed about the pointer variable. So declaring of the pointer variable, you just simply type like integer, then static, then pointer name, like pointer name is N, A, B, C, any pointer name, or type static and the pointer name. Okay, where is a type of the data pointed like integer, character, or doubles. For example, here you just see integer, static, this is the keyword as using to declare the pointer, and relational number you just see static and R, and then this is pointer to pointer, means double static. So how to address a pointer? So addressing a pointer, it's a thing using, means operator using in that, which is the AND operators, which give the memory address to the variable. To writing this, simply use and the variable name like and then N. So you just simply write this with your variable name to addressing the pointer. Then we have the memory addresses. Let's suppose A, which is equal to 100, and it will it will available on the index number 0, 1, 2. Okay, so when we just print this A, so it print 100, and it will get the memory address of 1024 with the help of that AND operator, because this is available on the address of 1024. If this 100 is available on that one, so that's mean that 1020. So this is a simple logic of how to declare this pointer. Let's just see the coding example of the pointer. So as you can see here, I just define the header files right now, and then integer main. So here I just define integer, which is a variable which is equal to 20. So this is the actual variable of variable what I declare here. Now integer static, I just told you that pointer used static, and P. Here I just write IP. So this is the pointer variable. Now IP, which is equal to and variable. So it will store the address of the pointer right here. Then cout, which is, here I just write the value of variable and then variables. Okay, so that will print the value of the variable, and then cout, which is the variable, and here I just write end line. So simply it will print the variable value. Okay, now I just store the address of the IP pointer variable. So cout, and then address stored in IP variable. Okay, so let's close this code, and cout here is IP and line. Okay, so it will simply print the IP variable here. Now here I just write cout, which is the value of static IP, means pointer IP variable, and here I just write variable. Okay, and then cout our pointer variable, which is end line. Okay, so here it access the value at the address available in pointer. Okay, so simply it will access that address of the pointer available in the the access the value at the address available in the pointer. Okay, and at the last return 0. Okay, now just check the output. So run as a module, and it is running. So as you can see here, the expected output for that code here is, it will print the value of the variable, which is 20, then address is stored in the IP, which is, so this is the address which is stored in the variable. Okay, and then the value of that variables, I mean that pointer variable here is 2, because IP which is equal to that variable. So I just write here, I just store the address of that variable in the IP. Okay, so this is a simple example of the pointer in the C++. Hope you understand now the logic of the pointer. If you not understand, please let me know. Thanks for watching this lecture.
Welcome to this lecture, and in this lecture we are going to talking about the null pointers in C++. It is always a good practice to assign the pointer null to a pointer variable. In case you do not have exact address to assign, this is done at the time of variable declaration. A null pointer that is assigned null, which is called a null pointer. So you simply write null as a keyword for declaring the null pointer. The null pointer is a constant with a value of 0 defined in several standard libraries, like including a string here, like just see, I just write, like here I just write hash include, and then input output string. Okay, then using namespace std integer main function. Okay, now here's time to define the null pointer. So static ptr for the pointer, and which is equal to null. So this is null, I just choose pointer as the null here at the time of variable declaration. So cout, which is this is, or this value of ptr is, and here I just write pointer. Okay, and then return 0. Okay, I just run this code, and here you just see this is the value of the pointer, and the value of the pointer here is null, and the null is also called 0. On most operating system, programs are not permitted to access memory at address 0, because that memory is reserved by the operating system. However, the memory address 0 has specific signification. It signs that the pointer is not intended to point to an accessible memory location, but by convention, if a pointer contains the null, means 0 value, it is assumed to be pointer to nothing. So simply this is the concept of that one. Okay, so hope so you just understand the logic of the null pointer. If you not, please let me know. Thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the pointer in the array, or array as a pointer. Pointer and arrays are strongly related. In fact, pointers and arrays are interchangeable in many cases. For example, a pointer that points to the beginning of an array can access that array by using either pointer arithmetic or array style is indexing. Let's just see the example of that array as a pointer or pointer as an array. So here I just write that std and then integer variable, and the variable of array here is max. okay, which is equal to, I just write here 10, 20, 30. 3 arrays here is 10, or I just write 100, 200 and 300. Okay, then integer static ptr as the pointer variable, and here I just write ptr which is equal to variable. So for loop, and here I just write integer I which is equal to 0, I which is less than this variable pointer which is array which is max, and I plus plus. Okay, now here I just write constant. So I just declare a constant here. So constant integer max, and which is equal to 3. Okay, so I just simply declare constant as a keyword and integer max which is 3. So this is 3 indexed array. Okay, now see out here is, I'll just write address of variable, and then here I just write double backslash the value of I, and then here close this code. Okay, now see out which is ptr as a pointer variable name, and then end line. So this is the static here. Okay, now I just copy this and see out again for the value of the variable, and which is I, and then it will print this pointer. So first one without pointer and then with pointer, and then I just point the next location which is ptr and plus plus. Okay, so simply the increment operators, and return 0. Run this code, and yes, and you can see here the address of 3 locations and the value of 3 location. You can see here this is the address of the index number 0, index number 0 value, index number 1 address, index number 1 value, index number 2 address, and index number 2 value with the help of these pointer as an array. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to talking about the void pointer in C++. Void pointer or generic pointer is a special type of pointer that can be pointed at object of any data type. A void pointer is declared like normal pointer using the void keyword as a pointer type. Like in our last lectures, we are just declaring pointer as an integer keyword, but here we just simply declare the pointer with a void keyword. So void means nothing, means it will return 0 to us. So pointer defined using a specific data type cannot hold the address of the some other type of variable. For example, it is incorrect in C++ to assign the address of an integer to a pointer of the type float. So now here we just discussed about the void pointer example. So the syntax of simply the void pointer here is, so you just simply write void and then static and ptr. But in our last lectures we just declare pointer like integer and then ptr. Okay, so now we just check the full example of this void pointer. So here I just write hash include, and then here I just write iostream. Now using namespace std and integer main. So now it's our main function right here, and inside the main function I just create a keyword of void, then static and pointer. So pointer is simply the variable to this void keyword. Okay, and then here I just write float f which is equal to 2.3. This is simple, the value of the float which is f is equal to 2.3. Then ptr which is equal to AND operator to address this pointer, and f is a keyword, is a variable of float data type. So float is a pointer of void right here, okay? Means this float is a pointer of void. Now simple, I just write cout and then AND operator f. It will print this float value and then AND line. Now it will print ptr. Means here it will print the address of that pointer, and then it will print after that another cout. It will print the pointer value. Now return 0. Now I just check the output, and as you can see here that here the pointer is given the value of address f right here, and then you just see the output shows that the void pointer ptr stored the address of a float variable f2. You can see here first it will show you the address, and then it will show you that the void pointer ptr is showing, means it's stored the address of a float variable. So this is a simple example of the void pointer in C++. If you find any of the problem regarding to this lecture, please let me know. Thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to start working with strings in C++. So creating and initializing strings is a straightforward proposition and fairly flexible. So we know that string is a collection of characters only. Let's again have a look at string and learn more about it. There are two different types of string in C++. First one is C style string, and another one is std string, which is a part of standard library. So in this lecture we are focused on C type string only. So C style string, that we can think of a string as an array of characters. Like here we have the index, like the elements are S, A, B, F, and then index mean we have the index on S is 0, 0, and then 1, and then 2, and then 3. So this is a simple C style string with the characters of an array. Let's just see the example of that how we declare the string with the array. So I just already defined hash include iStream, and then using namespace, and then main function right here. So now I just write character to taking the string, then character variable here is string, and then create then empty array, and then here I just write hello. So hello is our string here. So integer I, so I just take an integer which is I here, then I just take here I just write character string hello, and then cout, which is simply I just print a string here. So end line, okay, and then return 0 right here, okay. So in this example we print the whole string at once. Now let's see the result of that. So you can see here hello is our string here, so we just print this string with the help of arrays. So this is a simple example and the beginning example of the string. If you find any of the problem regarding to this lecture, please let me know. Thanks for watching this lecture. Hello and welcome to this second lecture of this string, and now see we are just creating an example of printing the individual characters of a string using for loop. Simply I just paste the libraries and the main function right here, and then characters. character and string, which is the array index, is equal to, here I just write hello. Now integer I, which is the for loop, so I just take the for loop here, because we are just taking the individual characters, or we are just printing the individual characters of a string using for loop. So I, which is equal to 0, and then I, which is less than 6, and I plus plus. Okay, then cout, which is str, and here I just simply print I. So I is our this character here, so I is equal to 0, and then here I just write return and 0. So I just run this code right now, and you can see the hello right here. So in our first example, we print the whole string at once, where whatever in second example we print a character of string at each time. As you can see here, just see here that we have the result of hello right here. Okay, so if you find any of the problem regarding with this lecture, please let me know. Thanks for watching this lecture.
Welcome to this lecture, and in this lecture we are going to talking about the string taking as the input. In most program environment, the standard input by default is a keyboard, and the C++ stream objects defined to access in cin. For formatting input operation, cin is used together with the extraction operator, which is written as the greater than sign. This operator is then followed by the variable where the extract data is stored. Let's just come to the example. Here, as you can see, I have a keyword which is cin, and here is an operator which is the greater than sign. Cin is used for accepting data from the keyboard. Remember that. The operator here, as you can see, this is called the extraction operator or getting from operator. The extraction operator can be overloaded. Mean if I put the age right here, so this extraction operator can be overloaded when I just put the value here is 25. I just simply put the value here, so this extraction operator is overloaded right here. The extraction operator is similar to the program what we written in C programming language, which is scanf, but here in C++ we use cin, but at the traditional language like C we use scanf right there. Cin is the object of iStream class, and the data flow direction is from input device to the variable. Due to the use of input statement, the program will wait till the user types some input, and that input is stored in the variable. Let's just see, this is the cin right here, and I just put 25 value right here. So the input stream means the program will wait. If I didn't put this value, so program will wait till the user type some input, and that input will be stored in the variable, and that will give you the result. Let's just go to the coding example and we just see how this code is worked. Now come to the code. Here, as you can see, I just print integer age and then cin and age. The first element declare a variable of type integer which is called age, and the second extract from cin a value to be stored in it. These operations make the program wait for input from cin. Generally, this means that the program will wait for the user to enter some sequence with the keyboard. In this case, note that the character introduced using the keyboard are only transmitted to the program when you enter or you just return. This key is pressed. Once a statement with the extractions operator or cin is reached, the program will wait for as long as needed till some input is introduced. Let's just go to the coding example and we just see how this program or code will work. Here I just write that hash include IOStream. This is simply the library of IOStream, and here is right namespace std. Now integer and the main function right here. So this is simple, the main function. Now our coursework is started right here. Integer I just told you, I just declare a variable which is integer and it is called I. Then cout, and cout here is I just write that please enter an integer value. Got it? Now I just define cn right here, and here I just write I just taking the input from this I. So here my variable is stored in the cn, and then I just define one other logic right here. The value you enter is, and here I just define I. Okay, now I just write this is return 0. Hope so you understand. Now let's just run this code. As you can see here, I just print this code, and it's taking the user input. I just told you that due to the use of input statement, the program will wait till the user types some input, and that input is stored in the variable. So this program is waiting for me. I just write here, which is 25 right here. When I just print enter or return, you can see here this will give me the result right here. Sorry, this is not the exact program what I am just running right here. This was the old program. Yes, you can see here the value you enter is 25. So this is the simple value what I just enter right here. It is 25, and the 25 right here. We understand the cin logic right here. Let's just see how this program flow is work. We have, let's suppose, a keyboard right here. Okay, and here we have cin, and then we just provide this extraction operator right here, and then we have the variable right here. Okay, now you just see here, we just taking the user input from the keyboard, then it go to object what is stored in the cin. Okay, cin is simply the keyword. Then it will go to the extraction operator, and using the extraction operator it will store the value and return back the value and go to the next operation. This is the simple work what we done with the cin. How we take the output means cout, how this cout is worked. Let's just see. Cout is opposite of the cin, and we just see how this cout is worked. Let's just see we have this screen right here. Okay, and this screen. So after getting the variable and variable return the value, so after the variable we have the insertion operator. This is extraction operator, and this is the insertion operator. Means in cin we use extraction operator, and cout we use insertion operator. So insertion operator gave the value to cout object, and that object will be printed like this on this screen. Hope so you understand now with this example. So as you can see, extracting from cin seems to make the task from getting input from the standard input pretty simple, and this is pretty straightforward. But this method also has a big drawback. What happened in the example about what we just using right here, if the user enters something else and they cannot be interpreted as the integer? Well, in this case the extraction operations fail. Okay, let's just see, like here I'm just running right here. So you can see here it doesn't taking the value from the string. I mean that. So this is a big drawback of this program, as this by default lets the program continue without setting a value of the variable. You can see here, and proceeding the undetermined result if the value of means I is used later, or if the value of the I is something else. Now we come to the main program, that how we take the user input as a string. So for that purpose, I am just removing this logic right here, and for that purpose we just use get line string. So the get line string is a standard library, or you may say this is a function that is used to read a string or a line from an input stream. It is a part of the string header. The getLine function extracts characters from the input stream and appends it to the string object until the determining character and encounter. While doing so, the previously stored value in the string object str will replaced by the input string if any. We just see the syntax of this. So here we have, let's suppose iStream, and that we are just defining the get line right here, and then iStream and iStream, and then I just write that this is the iStream is. So is an object of the iStream class which is tell the function is above the stream from where to read to the input from. And if you are defining this str as string, so it is a string object, remember that, and the input is stored in the object after being read from the stream. Okay, hope so you understand. Now let's just come to the example, and we just see the small example right here, and here is defined with the place of variable we just replace string str, then cout, okay, insertion operator, and please enter a name. Okay, I just write here this is get line. Okay, and here in the get line I just define cin and which is str. Okay, now I just define cout, insertion operator, and here you define that hello, then insertion operator, and I just pass parameter as the str, insertion operator, and here I just write welcome to this code, and here I just defining that /n for the single line break, and this is return 0. Save this code. Here I just debug this code here, so my debugging is off because of this program is opening. So build and run, and you can see here, you can see please enter a name. So here I just write hi. Okay, you can see hi, hello, hi, welcome to this code, or I just write that this is C++, so you can see hello C++, welcome to this code. So this is a simple program what we just run using the string, or we just taking the string as the input. Hope so you understand now with this program. If you find any of the problem regarding to this code and regarding to this lecture, please let me know, and thanks for watching this lecture.
Welcome to this lecture, and in this lecture we are going to talking about taking the multi-words string as an input. Let's just see this example, like we are taking the input of the string that consists of more than one word by using cin.getLine. Let's see an example that here I just write a string name which is the 20 characters right here, and here I just declaring the string as a name, and then cin.getLine. Okay, so this is getLine, and then here I just simply define the name and then size of method right here. Okay, so we just already discussed the size of and then name here. So it will take the string as an input in the multi-line or the multi-word strings. Okay, so cout, and then it will print the name and end line. Okay, so it will simply print this string and then return 0. Okay, so now I just run this code, and then learn in hub. So you can see it will take the learn in hub with white spaces. So cin.getLine and the name and the size of name. So cin.getLine take 2 arguments, remember that, and the string variable and the size of that variable. We have used size of operator to get the size of using variable which is name. So this is a simple logic that we just get means cin.getLine, and we just taking this string with white spaces too. So if you find any of the problem regarding to this lecture, please let me know. Thanks for watching this lecture. Welcome to this lecture, and it's time that in our last section we are just working with pointer. So it's time to get a string with pointers, means we are working with an example of pointers and the string right here. So let's just see that example. So character, name, and then the empty string right here, and then string name is learning. Okay, now character, and it will store the pointer right here. So this is a pointer p, so p which is equal to name. Okay, for a string only this declaration will store its base address. You can see here, so it means this string only only this string declaration will store its base address. Now I just use while loop. So while static p and not equal to, here I just write /0. Okay, and then cout, which is static p, and then p++ for the increment operator, and then return 0. Okay, run this code right now, and here is a problem, which is while loop, and yes, it is. Copy this and paste it right here. Okay, now I just run this code, and yes, so you can see here it's print the learning. So in this example, since p store the address of the name 0, you can see here the address of the name 0, and then therefore the value of static p is equal to the value of the name 0 right here. For example, like here I just write s, means in the place of 0 I just write s. So in while loop, the first character get print and p++ increase the value of the p by 1, so that now p+1 points the name 1. This continues until the pointer reach and the end of the string. For example, before static p becomes equal to /0, so it will take only the user input, means it will take the result as the character string, which is the name of learning. So this is a simple example of pointers with a string. So if you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Thank you. Welcome to this section, and in this section we are going to start working with dynamic memory and the dynamic memory allocation in C++. Let's just start working with that. Suppose you want to put a toy in a box, but you only have an approximate idea for its size. For that, you would require a box whose size is equal to approximate size of the toy. We face a similar situation in C++. Also, when we want to input a sentence as an array of character, but are not sure about the numbers of characters in the array. Now, while declaring the character array, if we specify its size similar that the size of the input string, then we get an error because the space in the memory allocated to the array is less than the size of the input string. This is the same as a case as trying to fit a big toy in a small box. If we specify its size much larger the size of the input string, then the array will be allocated a space in the memory which is much larger than the size of the input string, thus unnecessarily consuming more memory even when it is not required. This is like putting a small toy in a large box. In the above case, what I just discussed here, we don't have the idea about the size of an array until the compile time, when computer compiles the code and the string is input by the user. In such cases, we use new as operator. But before going to the new operator, let's have a look at two parts in which our memory is divided. These parts are like stack and the heap. Memory from the stack is used by all the members which are declared inside the functions. Note that main is also a function.
And heap is this memory is unused and can be used in dynamically allocated the memory at the runtime. Let's just discuss the new in the memory allocation. The new operator is used to allocate the memory at the runtime, and the memory is allocated in bytes. Let's first see how to allocate a variable dynamically. So you just use int static pointer, which is equal to new integer. By writing new integer, we allocate white space, means we are allocating the space in the memory required by an integer. Then we assign the address of that memory to an integer pointer, which is ptr, and we assign the value to that memory as follow, like static ptr, which is equal to 4. Thus we allocate this much space in memory that hold be required by an integer, and then assigned the address of that memory to a pointer ptr and assign the memory a value of 4. So when dynamically allocated some memory to a variable, we actually use the heap memory. Let's just see the example of that. So here we are just working a very simple example. So hash include, sorry, it's I just copy this one and then paste it right here, and then here I just write integer static ptr, which is equal to new integer. So here I just use new as a keyword right here to allocate the memory at the runtime, and then static ptr, which is equal to 4. Okay, and then here I just write cout, which is static ptr, and then end line. Okay, and then return 0. Now I just run this code, and you just see the output, and which is the memory location here is 4 because the static ptr is 4. So we just combine all the above step, means all these coding step in this example, and we have just seen how to dynamically memory allocate a variable. Now let's after this lecture, we are just allocating the array memory dynamically. So if you find so far any problem regarding to this lectures to memory location, so please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to discuss about the dynamically allocating memory in array. The main use of the concept of dynamic memory allocation is for allocating array when we have to declare an array of specifying its size, but are not used like about the size. Consider a situation when we want the user to enter the name but are not sure about the number of the characters in the name that the user will enter. In this case, we will declare an array of characters for the name with some array size, such that the array size should be sufficient enough to hold any name entered. Suppose that like we have the array size of like character name, which is 30. Okay, so and if the user entered the same having only 12 character, then the reset of the memory space which was allocated to the array at the time of its declaration would become waste, thus unnecessarily consume the memory. Means when we just enter when we just take the character name, which is 30, and the user enter only 12 character, so our left memory will be waste. In this case, we will be using the new operator to dynamically allocate the memory at runtime. So we use the new operator as like our old code where we just use. So let's just see the example of that. So here I just copy that and then paste it right here, and here I just write integer length. Okay, and length, and then take one another integer, which is sum is equal to 0, and then here I just write cout, which is I just write enter the number of students in the group. Okay, and then here I just write end line.
Okay, first I just take the integer as a length and then sum, which is equal to 0. Now cn, which is length. Okay, so I just take the user input as the length right here, and then I just write integer static marks. So using the pointer here, so marks which is equal to new, and I just create a new as the operator right here, and then integer which is length. Okay, so this will print this length right here. Now cout, which is, I just write enter the marks of the student. Okay, and then end line. Okay, now I just use for loop, and for I, integer I which is equal to 0, and then I which is less than length, and then I plus plus. Okay, so here we just entering the marks of the student. So cn which is equal to, here I just write static, and then marks plus I. Okay, and then we just go to the for loop again, and then creating another for loop which is integer I which is equal to 0, and then I which is less than length, and here I just write I plus plus. So here I just simply calculate the marks of the sum. So sum which is plus is equal to static and marks plus I. Okay, and then cout which is sum is, and then I just simply print the sum right here, and then end line. Okay, and then return 0. Let's just see the output and enter the number of students in the group. So I just write 5. So enter the marks of the students, so 25, and then 26, 23, 24, 28, and you can see the sum of that all are 126. So in this example, we are calculating the sum of the marks of the students in the group. Since the different groups have a different numbers of students, therefore we are asking the numbers of students. For example, the size of an array, and every time we are running the program, in this example, the user entered the size as like 5. So integer static mark which is equal to new integer length. You can see here. So this is like we declare an array of integer and allocate it some spaces in the memory dynamically equal to the size which would be occupied by the length. The number of integer does it allocate a space equal to the length and static size of the integer. Okay, and we assign the address of that assigned memory to the pointer marks. The rest of the step must be clear to you, and we call the array dynamic because it being assigned the memory when the programs run. We made it possible by using the new operator. Thus dynamic array is being allocated memory from heap, unlike other fixed array which are providing memory from stack. We can give an example of these dynamic array, and there is no limit to it. So hope so you are clearing dynamic memory allocation with the help of array. If you not understand any of the concept regarding to this lecture, please let me know. Thanks for watching this lecture.
Welcome to this lecture, and in this lecture we are going to talking about the date and time in C++. The C++ standard library does not provide a proper date type. C++ inherits the struct and functions for date and time to manipulate from C. To access date and time related function and structures, you would need to include ctime header file or ctime library in your C++ program. Let's just see the coding example of the date and time. So suppose that you want to retrieve the current date
current system date and time either as the local time or as the coordinates universal time, mean UTC. So let's just see the example like that. So for that I just write hash include and then input output stream. Then here I just write hash and include one another header file which is C time. So I was talking about that header file which was C time. So using namespace that std and integer main function. Now here I just write time underscore t and now which is equal to time, and then close this code right here. So that will get the current date and time based on the current system. So time underscore t and then I just write now and which is time, and the time here is 0. So this return the current calendar time of the system in the number of second, and it's elapsed since January 1st 1997, mean it will take time from January 1970. If the system has no time, so it will return 1. Okay, then here I just write character, and the character which is I just write the pointer and then dt which is equal to C time, and then the C time parameters right here is I just write and now. So I just save the address of that here. So it will convert now string from. Okay, so it will convert now to string from. Okay, now here I just write cout and then I just write the local date and time is, and then I just write dt means this variable and then end line. Okay, now tm and then I just write static and gmtm. Okay, so that will convert now to tm construct for UTC time. Okay, and then which is equal to, here I just write gm and then time. Okay, and then here I just write and operator and then now. So it will store that address for the constructor, sorry structure. Okay, so dt which is equal to I just write here asc and time. So here this will return a pointer to a string that contains the information stored in the structure pointed to by the time converted into the form. Okay, and that will means constructor gm time. So that will return a pointer to the time in the form of tm structure, and the time is represent in the coordinates like universal time UTC, which is essentially Greenwich means GMT. Okay, so this is mean green. This means that the Greenwich Mean Time means GMT. So I just write simply here GMTM, and then I just close this code right here, and then here I just write cout, which is this UTC date and time is. Okay, and then here I just simply print dt, and then this is our variable here, and then end line. Now I just check the date and time right here, and yes, and as you can see here the local date and time is Monday September 3, and this is my time and 2018, and then the time on the UTC date and time is Monday September 3, and this is my 4/27 and 0.2 means 202 and 2018 on UTC date and time. So this is a simple example of how to get the current date and time with the help of C++ code. If you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the format time using the struct tm. Struct tm mean like this one, tm and then structure. Okay, so the tm structure is very important while working with date and time in either C or C++. This structure holds the date and time in the form of C structure as like this code. Okay, so this example which make use of various date and time related to functions and tm structure. While using structure in this lecture, I am making an assumption that you have basic understanding on C structure and how to access structure member using arrows operator. Let's just see the example of that one. So I just simply take some of the steps from my old lectures, which is time t and now which is equal to time zeros, which will get the current date and time based on the current system. Okay, then here I just write C out, and then here I just write number of seconds since January 1, 1997. Sorry, 19 and 70. Okay, and then here I just write simply print now, and then end line. Okay, so I just print this variable right here. Okay, and this is C out. Now I just write tm, and then it will hold pointer which is tm, which is equal to local time, and then I just write local time, and then I just hold the address of now. Okay, now I just print the various component of tm structures files. Okay, so C out right here, which is I just write year, and then I just write here 1970, and plus local time, which is the arrows operator, so that is the arrow operator. Okay, and then tm underscore year, and then end line, and close this code right here. Okay, now I just copy this, paste it for month, day, time. Okay, so here I just write month, and the month here is I just write 1, and the tm, which is the arrow of tm, and here I just write month. Okay, then here I just write day, and then here I just write day. We have the no day here right now, so I just remove that one, and then I just write local time, which is the arrow operator of tm underscore m day. Okay, now here I just write time, and then here I just write month, and this is day. Okay, month, day, and then here I just write time, and the time here is 1 plus local time, which is the arrow operator of time hour. Okay, then I just write count means C out 1, and then it will simply print time in the minutes, and time in the minutes right here, and then it will print 1 plus times in seconds. Okay, so I will just get the entire format of the time right here. First I will get the time in the years, then month, then day, and then time in the time, and then seconds, time in the hours, and then seconds and the minutes. So now I just run this code and check the output for this code. So as you can see here, first I will get the seconds since January 1970, so these are the seconds right here, and after that the year, here's our
2088, and then month is 9th, and day is 3, time is 10 seconds, minutes are 34, and the second here are 43. So this is a simple example of the getting format of time using the struct tm. If you find any of the problem regarding this lecture, please let me know, and thanks for watching this lecture.
Welcome to this lecture. In this lecture, you will learn about the structure in C++ programming language. We will see in this lecture what is the structure, how to use it, and how to define it. Let's just see. This is a simple code of the structure number. So struct here is a keyword, and the number is any number right here. Now we see a structure is a collection of variables of different data types under a single name. It is similar to a class in that both holds a collection of data of different data types. For example, you want to store some information about a person, his or her name, citizenship number, or a salary. Let's just suppose here I just define name. Sorry, this is the name as a variable. Then I just define number to that, and then salary or city. These are the four variables what I just defined, or these are the four information what I stored here about the person. However, in future you want to store information about the multiple person. Let's just see, this is a information of a single person. If you want to store the information about 2 persons, 3 persons, or 4, let's just see, we have the person right here and here 4 persons. Now you need to create a different variables for each number per person. Let's just see, for person number 1 we have the name 1 like this, number 1, salary 1, and city 1. For person number 2 we have the name 1, number 1, salary 1, sorry, the name 2, number 2, salary 2, and the city 2. And same like 3 and 4, for we get 3 and 4 right here. So you can easily visualize how big and messy the code would look. I mean, if we declare like this logic 1 2 3 4, like these are the 4 variables right here, and as you can see, like here I just copy. So these are the informations for the 4 numbers, like 1 1 1 and 1, and here 2 2 2 and 2, and like 3 3 3 and 3. So you can see here how this code is look like. It's a big. Okay, so also, since no relationship between the variable information would exist here, it would going to be a you may say a daunting task. Okay, so a better approach will be to have a collection of all related information under a single name like person. Here I just define struct as the person, okay, and use it for every person. Now the code look much cleaner, reliable, and efficient as well. So this collection of all related information under a single name person is a structure right here. Hope so you understand now. So this is the simple structure right here. You can see here, this is a structure of a person. Let's just see how we create a code right here. This is the declaration of the person, like struct and the person. Sorry, this person spelling is wrong. This is the person. Now I just define character for name, and the name character here are 50. So 50 is a character names here. Now integer age, and here is defined that float salary and character city. So character cities are also a 50 digit character.
what it done right here, 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 and here. I just define the character for that. Character means it always take the string of 50 words, means the 50 alphabets like A, B, C. So it will take only the 50 alphabets right here. Then you just define the age, then float, salary, and the character city right here. Now, hence as structure person is defined here with the 4 data members with the name, age, salary, and the city. When the structure is created, no memory is located. Remember that. The structure definition is only the blueprint, you may say, for the creating of variables. You can imagine it as the data type. When you define an integer like here, you just define the integer like here, I just define integer a. So the integer specifies that variable a can hold integer element only. Similarly, the structure definition only specifies that what property a structure variable holds when it is defined. Remember to end the declaration with the semicolon is must right here. Okay, like here it is must to add the semicolon after this structure's end. Let's just see how to define a structure variable. Keep this at the side. Like here we have this person, and the person name here is, you may say that is cat. Okay, hence a structure variable cat is defined which is of the type of structure person. When the structure variable is defined, only then the required memory is allocated by the compiler. Considering you have either 32-bit or 34-bit operating system, the memory of the float is 4-byte, memory of integer is 4-byte, and the memory of the character is 1 byte. So this is simply the memory location, how much memory will be taken, like this. Now we just see how to access the member of the structures. Let's just see here. I have person like age here, and age of the person is 50 right here. Okay, suppose you want to access the age of the structure variable like cat and assign it 50 to it. And assign it 50 to it. You can perform that task using the code like this. Now we see the coding example of the structure and see how to implement this code. I just define hash include IO stream using namespace and std. Okay, how we declare the structure here? We declare a structure outside the main function like this one. Here we use the structure. Okay, so our structure is already created right here. Now we go to the main function. Here I just define person which is p1. This is the person name, so I just getting the person name right here which is p1. Now I just write cout which is enter your name. Okay, then I just write cin.get, and here I just write enter here cin.get, and here I just write p1.name, and the name here is 50. Okay, you understand now. At first stage I just write that please enter your name, and it will get the value of the name right here, and 50 is a character set right here. Now I just write cout, and the cout here is enter your age. Close this code right here. Then I just write cin, which is p1 dot get the age. Then I just write cout enter salary, get the salary right here, and take the user input from the salary, which is p1 dot salary. Sorry, this is salary. Hope so you understand now. Now I just write cout, which is enter your city name. Close this code right here, and then here I just write cin dot get, and then I just write p1 dot city, and the city here is character set of 50. Hope so you understand now. Now here is write cout. So first of all, I just run this code, return 0, and built and run. So we have an error right here, which is the using namespace std, and this is istream right here. I just declare this as the using namespaces, and here this is the person number 1, and I just see there is an error right here, which is cin dot get method, and this is simply the get method, no need of extractions operator right here, and run this code. So the name here I just write Kate, 25, salary 50, and please enter your city name, because this city name is not here yet, because I just not declared the right city here, and I just write that cout. And so before proceeding the cout, we just set our this code right here, because this is the cn operator, cn for taking the user input. So your code be just like this one. Now cout, here I just display the information, remember that. I just write /n display information here, and l for the end line. This is information. Okay, now cout here, which is equal to name, and then here I just write p1 dot name, and at the last end line. So end line, also called line break after this statement is executed. Now this code, and afterwards we just go to the age, then cout, that will print salary, and at the last that will print the city. Now run this code. The name is Cat right here, the age is 25, and the salary is 50. City name is Toronto. You can see the display information, the name here is Cat, and this is how we just did a little mistake right here, which is name, age, salary, and the city. Now you just see, the information is name is a cat, age is 25, salary is 50, and the city is Toronto. So this is how we just declare our structure So you just also declare this for the person number 2, person number 3. So simply just change the name right here, like this one. Here you just simply change like person P2, okay? And then here you just write that cn enter your name, then get the name, and then cout and cn like this one. So simply change the P2 right here with for person number 2. I just simply gave out the little example. Like here I just write P2, save this code, and here name, age, salary, you can see here, and here you can see this is enter your name 2. Okay, this is the simple code what you just done right here with the help of this structure. So I just declare this code right here. So you need to declare here because this is getting the information like this one. Okay, hope so you understand now. If you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture. In this lecture, you will find relevant examples that will help you to work with pointers to access data within the structure. A pointer variable can be created not only for native types like integer, float, double, etc., but they can also be created for user-defined types like structures. We have a code right here which is struct number. So this struct is a keyword which is used for structure. Here I just write integer image, then float real. This is a simple syntax what I just created right here, and close this code right here. Now as you can see here, this is a simple structure what I just created right here. So I just pointed this image to the pointer, and here I just want pointer as an image and then pointer as the real. We have address 1 right here and address 2 right here. The pointer main concept is to storing the address. Hope so you understand. Now let's just suppose we have a complex pointer right here. Simply I just write complex and then asterisk ptr, which is equal to and operator and then variable 1. So if this variable will run, so that will go to store the value like here in image, which is 1000. This is a simple address what I just created right here. Okay, and this is the address of this image. Now see what I just mean right here. As you shown right here, we have create an array of structure type complex size 2. Like here you can see we have the complex size, or I just leave it right here, and here I just write complex. Okay, and then I just write asterisk ptr, which is equal to and operator and var for the variable representation. So simply I just create a complex array right here. Okay, now we just come back to our examples. So I just remove this all and start from beginning. Here as you can see, this is our complex variable, or you may say this is a complex array of structures which is a size of 2. Now then created a pointer of complex structure types and assigning the address of the array, which is var. I just assigning the address of the very array is var1 to this pointer. You can see here I just assign this address var to this pointer. Okay, now the pointer ptr, you can see here, this is the ptr pointer. It's contain the address of the element base address. I just told you, let's suppose we have the address of this image which is 1000. Okay, so that will store the address right here, and it's contain the address to the first element which is our base address in the structure array, which is variable number 1. And we can use the pointer to access all elements inside the array by iterating the pointer using ptr++. Let's just see the coding example of this pointer and see how this pointer is worked. I just remove this complex pointer right here, and here I just write distance. So our structure is a distance right here, so I just creating the distance here, and here I just write inches. I just include the libraries here, hash include iStream, and after this I just write using namespace std. Okay, now after this representation of the structure, we just go to the main function, integer main right here, and inside the main function I just write here which is distance. So distance is our this structure name right here, and as I just told you that this is static ptr for the representation of the pointer, and here I just write d for the distance. Now ptr, which is equal to, I just write d. This is end side to storing the address. Okay, simple is the meaning of this end side is to storing the address in the d. Just make a concept right here. I will explain this program after this completion of this code. So here I write cout, which is enter feet, and after that I just take the user input. Here in the user input, first of all I just take the pointer which is the stored address, which will store the address of the feet, and then I just write that cout, which is enter inch. Okay, and then here I write cin, and then static ptr dot inch. Okay, so first of all it will store the address of this feet right here, and then address of the inch right here. This is the help of this structure. Then here I write displaying information, and this is end line. Close this code right here. This is information. Okay, now here I write cout distance, which is equal to, I write here static ptr, and that will print the store address of ptr.feet, and here I write feet, and after that I write that static ptr, which is dot inch. Close this code with inches, and that will return 0. Run this code, and here we have an error right here which is static ptr and the ptr which is d. So this is for the distance and integer main right here. So we have an error which is integer main function, and before the main function we have closed this value. So here as you can see we have the small D here because this is already taken with the C++ library. Enter the feet. I just write I am 6 feet and 10 inches. You can see here this is displaying the information that you are the 6 feet and 10 inches. And now we see how this program is stored the value and how it will give us the value right here. And like here you can see we have I am 6 feet and 5.10 inches. So you can see here that will display that 5.1 is the inches and the 6 feet here. Now here I just remove this and explaining the code right here that how this pointer is worked. So in this program, a pointer variable ptr, this is a pointer variable which is the ptr, and the normal variable which is d of the type structure distance is defined. This is the type structure which is the distance is defined. So you can see here this is our type structure. The address of the variable d is stored to the pointer variable. This address is stored in this pointer variable. Remember that. So that ptr is pointing to the variable d. So this ptr is pointing to the variable d. Means we are storing the address of d. So I just remove this, and here we are just storing the address of this pointer d in ptr. Okay, and after that we will show the value. So then the member of the function of the variable d is accessed using pointer. So we only access this using this d using pointer. Okay, you can note that since pointer ptr is pointing the variable d in this program, which is here you can see in the cn you can see start ptr dot feet or start ptr dot inches. This is a exact same cell, similar to like this is similar cell to the this one. These both are the similar to each other. And you may say that d dot feet, here you can see you just also write d dot feet. So d dot feet or ptr dot feet are exactly the same thing. Mean here if you write d dot feet, so you can write like that or you can write like this one. So this is the exactly same thing. So this is a simple program what I just created right here in the pointer. Hope so you understand now. If you're not, please let me know, and thanks for watching this lecture. Welcome to this lecture. In this lecture we are going to talking about convert character array to the strings in C++. The std string, or you may say the string in C++, has a lot of inbuilt-in functions which make implementation much easier than handling a character array. Hence, it would often be easier to work if we convert a string array to a string. Let's just see the coding example of that how we convert the string to the character array in C++. I just write hash include, this is hash include and a string. Then I just write hash include string dot h, or without that program will be work. Okay, using namespace std, and then here I just write integer main function. Firstly, I just create character m and take the empty array right here, which is equal to, I just write here hello I or hello, or you simply just write hello. Okay, now here is write string str. Now here is write integer I and close this code right here. Now we just take for loop I which is equal to 0. Sorry, this is the for loop I which is equal to 0. Then I which is equal to 0, close this code. Then I is less than, here is write size of m, and then I plus plus. I will explain this code after finishing this. So now I write string I and which is equal to m and pass the array as a I. Now see out which is str and I here. Close this code and return 0. Now here I just close this code, all code, and run this. So we have an error which is, this is the for loop, and run this code, and this code is running. You can see here I just convert the string, means the convert string to the character array. What is that mean right here, and what is the why we are just converting the strings into the array? So I just remove this code and explaining this code right here. So as you can see here, first of all I just add two libraries right here, which is hash include iostream and string.h. Then using namespace std, here as you can see here we are going to convert the string to the character array. So I just take character array right here, which is m is a empty right array which is equal to hello, or you may say this is equal to hello. Then I just take string str. So this string str is, you may say this is a variable to this string. Then I just take one another variable which is integer I. Now with the help of this for loop I just said that for I which is equal to 0, I which is less than the size of this m, and then I plus plus. Now here we are going to convert our string into the array, like str which is stored in I just take as an array which is equal to m and the array of I, and I just print after that cout which is str, and str is the I right here. Okay, so you can see here, first of all, after these variables, like here you can see, just remove this, and after these variables, means after taking these variables, three variables, so we are just taking the for loop which is taking I is equal to 0, I is less than the size of m, means this I is less than this size of m, means this size of array hello. Then you can see here, after this I just write that str which is equal to I, means that this str is equal to this I, and this I is storing the address of this character m. So str is I which is equal to m, the array of I. So these two statements are equal to each other, and then after that I just print the statement of str which is I. So I just print this statement at the last. So this is a simple code what is this creating, or which is converting the string to the character array in C++. Hope so you understand now this concept. This is confusing, but If you find any other problem regarding with this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture. And in this lecture, we are going to talking about the C++ program that will passing the structure to the function. So far, all structures used in the preceding example have been global, and hence were available to all the functions within the program. But if you have a structure local to a function and you need to pass it value to the another function, then it can be achieved in two ways. First one, you can by passing individual structure element and try passing the entire structure. Both these ways can be achieved by call both these ways can be achieved by call by values as well as call by reference method of passing the variables. Let's just discuss these. Now I just write that this is a structure and the structure is a date right here. Then this is a short day, short month, short is a data type, okay, and short is year. And after that I just write close this code and then b date. Okay, when an element of the structure is passing to a function, you are actually passing the value of that elements to the functions. Therefore, if it is just like passing a simple variable, unless of course that element is complex, such as the element of character. For example, as you can see here on your screen, this is our entire code, and this code is like passing the structure element to the function. Okay, now you can see here this function means here I just define function, and function here is b date, okay, or I just write that the coding example right here. So function number one right here I just write b date, or you just write b day for the birthday. Then here is write for month and for year. So this is for year and this is for month. So this function call invokes a function which is the function number one. This is the passing value of the individual structure element of the structure, which is b day. You can see here this function number one, and this is the equal to sign here. Okay, this function number one is passing the value of the individual structure element of the structure b date. The function can either receive the value of creating it shows a copy of them, which is called the call by the value, or by creating the reference of original variables call by the reference. If you want that the value of the structure element should not be alerted by the function, then you should pass the structure element by value, and if you want the function to alter the original value, then you should pass the structure element by reference. But remember that if one of the function element happens to be an array, it will automatically be passed by the reference, as the array cannot be passed by the value. That is all what I just explained right here is passing the structure element to the function. Now we see how we pass the entire structure to the function. Passing the entire structure make the most sense when the structure is relative compact. The entire structure can be passed to the function both way, by the value and by the reference. Passing the value is useful when the original value are not be changed. By passing by reference is useful when original values are be changed. Let's just see how the structure date right here, and this is our structure. Okay, but Here you can see we have short day, month and year. So you may say these are our function number 1 and function number 2 and so on. Okay. Now we see the coding example of this function, and here I just write that this is hash include stream using namespace std. Okay. Now here, first of all, I just create the function. This is called void display, and the display here is display the data. I want to display the data of the person. Here I just declare the function. Okay. Now I just write integer main. So this is our main function, and now I just define the structure right here. So this is a structure which is the person, and then here I just write character, which is the name, and the character size here is 50. Then integer age, and then float salary. These are our element of this structure. You may say these are our simply the function. Now here is write person is a p right here. Okay, or I just write this person here. Okay, so p is a capital right here. Now I just write cout enter, and this is cout enter full name. Okay, close this code right here. Now here I write cn dot get p dot name, or you simply pass the name. Okay, these are the two methods what you are just adding the cn. Now cout, which is enter salary, and then here I write cin p dot salary. Okay, now here I write cout enter age, and cin here I write p dot age. So this is simply the declaration of cin, which is p dot age. Now as you can see here, now I am just calling the function with the structure variable as the argument. Now here is write display, and the display here is, so I am just calling this function right here, which is display data, and the data here is p. Okay, so p is this person as the variable. Now I just create one another function right here, which is void display data, and person p right here. Okay, now cout, and cout here is slash n display information. This is for displaying the information here, and end line. Okay, now cout, which is display the name, and then print p dot name and end line. Okay, then here is write age and p dot age end line, and add the last salary and p dot salary. Here I just write return 0. We have an error right here, which is void display data, and this is the capital P for the person. Now as you can see, our program is running right here. So as you can see here, this program will ask the user to enter the name, age and salary. So here I just write name, which is hello, salary which is 50, and age which is 2. So that will display the information with the help of passing a structure to the function in C++. Then as you can see here, we have the variable P. As you can see here, we have the variable P, which is passed the function using this display data P. The return type of this data, display data, is void. You can see here this display data is return type of void, and the single argument of the type structure person is passed right here. So this is a simple program what I just created in passing the structure to the function in C++. Hope so you understand now with this example. If you not, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to run a program which is give two arrays, count all the pair, those sum is an odd number. And let's just go to the coding example of that and see how this approach is worked. After this program I will explain all the code and will show you that how this program is work. So here I just write hash include iostream. Then after that I just write that using namespace and std. Okay, now we'll go to the integer main function right here, and inside the main function I just define integer a. This is the array size a. I just take the array right here. Here I just write 9, 14, 6, 2 and 11. Okay, then I just write that integer b, and the b right here is the array, and which is equal to 8, 4, 7, 20. So we are just taking the odd numbers from these values. Let's just see, we have, I just remove this, and you will see that so let's just see, we have the two arrays right here, array number a and array number b right here. So this means that this program means that will only take the sum of the odd number only. Okay, that will take only the odd number from these values. Let's just see how this worked. So here I just write integer number n right here. This is the size of a, and then here I just write size of a, which is equal to 0. So I just take an array which is starting from the indexed 0. Now integer m, and then here I just write size of, which is the b value right here, and then I just write size of, which is the b, and the b is equal to 0. Now I just write cout right here, and before going to the cout we just going to firstly I just create a function here. So this is a functions that run the number of the pair. So integer count underscore pairs. Here I just write integer a empty size array, integer b empty array, integer n, and then integer m. So these are our parameters of this functions right here. Now start the code, and here I just define count underscore pairs, and which will print a, b, n and m. Close this code right here. Now integer odd 1 which is equal to 0. Okay, then I just write even 1 which is equal to 0. These are the two values that I just take here, even and odd. Then integer odd 2 which is equal to 0, and even 2 which is equal to 0. These are the count of odd and even number, or you may say these are counting the even and odd numbers only. Now see, here I just take for loop for integer I which is equal to 0, I which is less than n, and I plus plus. So this is our first for loop that traverse in the first array and count the number of odd and even number in them. I just take if statement a which is I, so that array will print I which is the modulus of 2, and then odd which is 1 plus plus. What does that mean, the odd 1 plus plus right here? I just simply did an increment operator right here, then even plus plus right here. First array is completed right here. For let's just suppose this array A is completed right here. Now we just turn to the array B. Let's just take for loop again. Integer I which is equal to 0, integer I which is less than m, and I plus plus. Then here just write B which is printed the array of I right here, and then the modulus of 2. Then here I just write, or I just set the increment operator for odd 2 and the increment operator for even 2. Now after this example, we just go to count the number of the pairs, like integer pairs which is equal to main is a type here, and odd 1, then even 2. So I just print odd 1, or I just multiply odd 1 with even 2 plus main again, and then odd 2 which is multiply with even 1. Hope so you understand. Now after this I will getting the return number of the pairs. So here I just write return give me the pair, okay, or give me the pairs. I just save this code. Now at the last return 0. Let's just run this code first, and we have an error right here which is in integer main function, which is integer a and 9, 14, 6 and 11 right here, then integer b which is equal to 8, 4 and 7 and 2 right here. So this is in curly brackets, not in the array size. Okay, run it again and check the error again. So we have an error like here again, which is cout and the count pairs. So this is our count pairs. Run it again, so you can see our program is run here. As you can see, we have get the value of 3 right here. How this value of 3 is coming right here? I just told you this is the program which is running the to array count all the pairs whose sum is odd number. Okay, we have two arrays right here, which is the integer value of n and m. I just told you that this task is to find the number of unordered pair formed of the element from both array in such a way that their sum is an odd number. If this is the even number, that will not taking any of the array. Like we have 2, so sum of 2 I divided by 2, so it is 0. 4 divided by 2, so this is multiplying. You do not multiply 3 with 1, or you do not multiply, like here the value is 11 with any of the edges 3, 4, 5. So that will only take the number whose you easily find the sum. So note that an element can only be one pair. Okay, remember that. So as you can see, we have the two input types right here. So first input type is this one. This answer is 3. I will explain this in later. First, I will create one another array and whose value is 2, 6, 4, and then B, which is equal to 8, 10 and 12. Okay, so this sum is 0 because these all are the dividable values 4, 6, 2, 8, 10 and 12. So that output will be 0 right here. Why this output is 3? Let's just see now. We have 9, which is the odd value. Sorry, 9 is divided by 3, so I'll cut this. 4 is divided by 7, I will cut this. 6 is divided by 2, 3, any number, I will cut this. 2 is divided by any number, 2 like, I will cut this. 11 is didn't divided by 1, 2, 3, so I will take this as the 1 right here. 1 plus. Okay, now I just go to another value. Here we have the value, sorry, 9, yes, okay, 9 is didn't divided by 3, so we will only take 2 right here because this is the even numbers. Okay, so 14 is divided by 2 and here the 6 is also divided by 2. These all values are divided by 2 without 9. Okay, so I just take 1 right here. I am just did a wrong right here. So 9 is didn't divided by 2. Now 8 is divided by 2, 4 is divided by 2, 7 is not divided by 2, so I just write 7 right here, and 20 is also divided by 2. So this is the sum of 3 values which is not divided by 2, and it will find the odd values which is 3 right here. You can see. Now we just see what is the approach of this thing. So count the number of odd and even number in both the array can answer to the number of the pair will be like this main odd. You can see I just remove this, and here you see main 1 and main 2. So these are the answer of the numbers of pair will be the main, even, odd 1 and even 2 plus odd 2 and even 1, because that here you just see this is odd plus even only, which is even, odd, odd. So that will only print the odd values right here. Hope so you understand now with this example that how we can print the two arrays, count all the pairs whose sum is an odd number. So that sum is an odd number, so that will 3. Hope so you understand now. If you not, please let me know, and thanks for watching this lecture.
Welcome to this lecture, and in this lecture we are just going to start working on our next section, which is Introduction to the Object Oriented Programming Language, means the OOP in C++. Let's just start. So first of all, we just check the goals what we covered in our C++ object oriented lectures. So by the end of this lecture, you should understand the 3 pillars of the object-oriented programming: inheritance, encapsulations, and polymorphism. But other than that, in our next sections, so we just discussed about the abstraction, polymorphism. So we just discussed about the polymorphism in this lecture, but interfaces and overloading and the inheritance and much more about the loops like classes and the objects. So then we just understand what is an object, then understand the object attributes, methods, and the events, and then understand how to program or use APIs. So the programming languages. Programming languages allow programmer to code software. There are 3 major families of languages are. First one is machine language, like what we just contribute with machine, then assembly language, and then high level language, what we are working with. So machine language compressed of ones and zeros only, means that will give you the result in the binary digits only. The native language, this is the native language of a computer. Difficult to program, 1 misplaced, 0, 1 or 0 will cause the program to fail. So as you can see here on your screen, this is our example of the code what we do in the machine language. So it will always take the input and output as the zeros and the 1 from keyboard. Then we have the assembly language. Assembly language are a step towards easier programming. Assembly languages are compressed of a set of elemental and commands which are tied to a specific processor. Assembly language code needs to be translated to the machine language before the computer processes it. So this is example of the assembly language. So this is also take an input and output as 1s and 0, and then you can see here add 1 and 0, so this one. Then we just come to the high level language, what we are working with. So high level languages represent a giant leap towards easier programming. The syntax of HL language mean high level language is similar to English, like we just say output and string, all that thing like print, double, float. So this is using the English words. So historically we divide high level language into 2 groups. First one is procedure language, what we are discussing last in our sections, like we are working with variables, storage, loops, discussion function, decision making functions, array, and date and time, and as you can see here all that thing. But now here we have the second group of languages, which are object oriented language. So what are the procedure language? Early level language are typically called procedure level language. So procedure languages are characterized by the sequential set of the linear commands only, what I just told you right now. The focus of such languages on structure base, like function, we just make an array, numbers, and loop abstraction and operators. So example of that is C, COBOL, and Fortran, Lisp, Perl, HTML, and VB script. So these are all procedural languages. Now we just come to the object-oriented languages. Object-oriented languages means, so here we are just reuse our code, means this is a concept of reusability in the object-oriented programming language. So most object-oriented programming languages are high level, like JavaScript and C++, and other than that we have the Python, etc. So the focus of object-oriented programming language is not a structure but unmodeling data, means you just design the pattern in these languages, and the programmers code using blueprints of data models called classes. So classes are also called the blueprint. Examples for object-oriented languages include C++ and the Visual Basic.NET and the JavaScript and Python, JavaScript, etc. Okay. Then we just discussed the object-oriented programming. Object-oriented means here we just discussed the objects, method, and the classes. So objects, which are the unique programming entity that has method and it has attributes and can react to the events, and the methods, things which an object can do, the verbs of objects in code using can be identified by an action word which is hide and show. So in the method we just using the hide and show method, which is used in abstraction level. We just discussed about the abstraction in our next lectures. Then we have the attributes, which things which describe an object. The adjective of object in the code using can be identified by a descriptive word enable back color. And then events focused external to an object and to which that object can react in the code, usually attached to an event procedure. Then we have the classes concept, which provides a way to create new object based on the meta definition of an object. For example, the automobile class. So like we have the class of car, and then we have the attributes like car means this is a type of car, model, shape, color, etc. Okay. And then we have the constructor, which is a special method used to create a new instance of the class, like a Honda Civic is an instance of automobile class. Then we just discuss the object-oriented encapsulation. So incorporation into a class of data and the operations in one package, and data can only be accessed through that package. And encapsulation is the technique of information hiding. Then we have the inheritance, which allow programmer to create a new class based on an existing class. Then method and attributes from the parent class are inherited by newly created class, and the new method and the attributes can be created in the new class but don't affect the parent class definition. Then we have the polymorphism technique, which create the method which describe the way to do something journal in form. For example, the driver method in the automobile class, and the polymorphic method can adapt to a specific type of object. Then we have the classes and object technique. A class is a type of that allows programmer to create the object, and a class provide a definition of an object described by an object, attributes, data, and the methods operation. And the object is an instance of a class, which one class you can have many objects as required. This is analogous to a variable and a data type. That class is the data type and the object is the variable. What is an API? API is standard form of like application programming interface. So this is the stands for application programming interface, and it's allow the programmer to extend the current language in included customized component. And most modern language incorporate APIs like ASP.NET and other languages. So solution with object-oriented design means this called an API that certain the custom car object and much cleaner code and reusable object. So these all things what I just discussed here in object-oriented programming language. So remember that object-oriented programming language is used for code reusability of an object. Means you just simply reuse your code again and again in many forms. Okay. So if you have any question regarding to this introductory section of an object-oriented programming language, please let me know. And thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to working about the classes and the object in C++. So the main purpose of C++ programming is to add orientation to C programming language, and the classes are the central feature of C++ that supports object-oriented programming and are often called user-defined types. In C programming language, we have the no concept of objects and the classes. But C++ is the advanced version of C programming language that have the object-oriented programming language, which is the core reusability concept. And a class is used to specify the form of an object and its combined data representations and method for manipulating that data into one neat package. So that data and the functions within the classes are called the members of the class. Let's just see how to declare the class. So when you are defining a class, you define a blueprint of the data type. That does not actually define any data, but it does define what the class name means. That is what an object of the class consists of and what the operations can be performed on such an object. So a class definition starts with the class keyword. And then you see the example of that. So here we just simply write the class name, which is a class, and here just name the give it the name of the class, which is a class car. So as you can see here, the class is defined, means class is a keyword which is defined with class car, and the class body enclosed by a pair of curly braces. A class definition must be followed either by the semicolon, you can see here, or a list of declaration. Okay, now I just check the example of the class right here. So here we have this different concept of private and then public and protected. We just discussed about these three in our next lectures, but here we just you simply make a little concept about that. Private means these data member classes are private, mean integer data and floats. So these data members of the classes are accessed within the class. Public data member data members you can access within the class and outside the class. But the protecteds are the data member class where we use protect in the encapsulations to hide our information, that no information shows to the user, etc. Okay, so here we just simply use private and the public right here. So private, I just write integer data, and here I just write data is 1, or I just write integer model and then float, or here I just write character color. Okay, then the public data member, here I just write function, and then here I just write model, which is equal to, I just write model is 2018, and then afterwards I just write here that float, character, which is the function of that one, means function number 2, and then here I just write color, and the color here is equal to, I just write the color is white. Okay, and then it will return color. Okay, so it will return the character right here. So this is the concept of the class what I just used with the private and the public. Okay, so these data members are accessed within the class. Okay, because this is the private data members. So you maybe notice the two keywords here, like public and the private. So the private keywords make the data and the function private, and the private data and the functions can be accessed only from inside the same class, what I just told you. And the public keywords make data and the function public, means public data and the functions can be accessed outside of the class. Here we have the class data members of models and the color are the private data members, where a function number 1 and the function number 2 are the public data members. If you try to access private data from outside the class, so similar throw error, means you just use exception handling with that. So this feature is introduced in object-oriented programming language, which is the data hiding concept. Now simply we just turn to the object. So when we just create a class or when we just define the class, so only the specification of the object is defined, means no memory or the storage is allocated yet. To use the access data and the access functions defined in the class, you need to create the object here. So
here I just go to the function, means here I just go to the integer main function, and then I just define, like, this is our class name, which is car. So I just simply call my class name right here and then create an object to that. So obj1 and then obj2. So I just call these two objects right here. So in this example, class car, the data member model and the color are the data members, and the functions 1 and the function 2 are the members of the function right here. Okay, so this is a simple concept of the classes and the objects in C++. In next lecture, we are just going to access the data members and the members of the function with the help of C++ programming. So if you find any of the problem regarding to that classes and the objects so far, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the accessing data member through classes. The data members are members of the function of class, can be accessed using dot operator with the help of object. For example, if the name of an object is obj and you want to access the function with the same name, like print name functions, then you will have to write obj dot print name. So the code like public, and then you just write print name, and then you just write simply obj. So this is our object name right here. So we just access this with the help of this dot operator. So accessing data members means the public data members are also accessed in the same way. Given, however, the private data members are not allowed to be accessed directly by an object. So accessing a data member depends solely on the access control of the data member. Let's just see the coding example of that. So simply I just write hash include and then rstream. I just declare the header files right here and then using namespace std. Okay, now integer main, and outside this main function I just write the name of the class. Class is a keyword here, and here I just write the class name, which is box. Okay, now here I just declare the access specifier. So the access specifier here is public. Okay, and then I just write double and then length. First I just declare the length to a box, then double, then here I just write breadth. So here I just write breadth to the length box, and then double, which is height. Okay, and then height of the box. So here I just simply declare the access specifiers and the data members. Okay, now just go to the main function. So first of all, in main function I just access I just declare this box as a class name, and then declare the type of the box, which is box number 1. Okay, then box is a class name, and then box number 2 as a type number 2 here. Then double, and I just take a variable name which is volume right here, and which is equal to 0.0. Okay, so it will store the volume of a box right here. Okay, now box number 1 dot height. So here I just call this class with the help of object, means I just going to access the data members of an object of the class. Okay, so with the help of this dot operator right here, as you can see here. So length, which is equal to 10.0, and then box number 1, and the box number 1, it's box number 1 right here, so b is small. Okay, so box number 1 dot length, which is equal to 6.0. Okay, and then here I just write, so it is box number 1, and then create an object to
the box type number 3, which is box number 1 dot breadth, which is equal to 7.0. Now I just create the box number 2 specifications right here, and I just simply copy that one, and then I just write for box number 2, okay, and then box number 2 and box number 2 here, okay. So simply change the value of that, so which is here I just write 13.0, and then the length right here is 14.0, okay. Now here after that box number 2 specification, I just give it the volume to the box number 1. So the volume right here is volume, which is equal to box number 1 dot height and multiply by box number 1 dot length and multiply box number 1 dot breadth, okay. Then simply C out, and the C out here is I just write volume of box number 1, okay, and then here I just write volume, which is end line. Now volume for the box number 2, so simply I just write here box number 2, box number 2, and then box number 2, okay, and the box number 2. Now return 0. So first of all, I just declare the integer main function, then class box, and then create a box of the class name, which is box, and then access specifier right here, which is a public, and then the data member of that access specifiers. Then I just declare the value for the box number 1 and the box number 2, means declare the two box types, which is box number 1 and the box number 2. Then store, then create a double as the integer, double as the data type of volume, and which will store the volume of the box here. Then a specification for the box number 1 and the box number 2. Then I just set the volume for the box number 1, which is simply the formula like multiply these all values, so it will give you the volume of that box number 1 and then box number 2, and then print this volume of box number 1 and box number 2. So this logic is very simple. So now just run this code and check the result for this code. So it is very important to store that private and protected member cannot be accessed directly using direct member access dot operator. So we will learn about that in our next lectures, that how to how to access the private and the protected data member with access, means using the access modifier, okay, or accessing the data member using the classes. So here is an error, which is where is an error, and then box right here, and this is box number 1 dot height. So I just misprint this height spelling, so change that and run this code again. And where is in height? Yes, that one. So height and the height right here, okay. Now I just build it again and then run. So you can see total volume of the box number 1 is 1420, and the total volume for the box number 1 is 420, and then the total volume for the box number 2 is 1820. So this is a simple example of accessing the data member with the help of dot operator. You can see here we just access these all data members of that access specifier with the help of that dot operator. If you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the class members functions in, or a class members of function in C++. A member function of a class is a function that has its definition or its prototype within the class definition like any other variable. It operates on only object of the class of which it is member and has access to all the members of the class for the object. So we have the two ways to define a member function right here. First one inside the class definition and another one is outside the class definition. To define a member function inside the class definition, we have to use the scope resolution, means like double operator sign, like this one, like double colon sign. So this is called scope resolution. Okay, we just also called in our maths like ratio. Okay, so operator along with class name and function name. So now I just declare the example like demonstrate function declare outside the class. So simply I just write hash include and then input output stream using namespace, which is std, and then here I just create a class which is like here I just create a class name which is any name you just want to give, like car. Okay, so this is a class name which is car, public access specifier right here. Then I just declare the string which is a data type of means data are data of that one. So string here is I just write BMW. Okay, and integer id, I just declare one integer id right here. Okay, now inside the class function, okay, so void, and void is print me. Okay, or just I just write print name. Okay, so this is my function name, and here I just close this function name with a semicolon. So the print name is not defined inside the class definition, remember that. Now I just write void print id. Okay, so here in this functions mean print id is defined inside the class definition. So cout, and the cout right here is I just write BMW id is. Okay, and then here I just write id. Okay, now after that I just go to the definitions of the print name using the scope resolution. Okay, like we just define the print name using a scope resolution, mean create the class, means here I just call the class which is void BMW, void car, and then scope resolution, and then here I just simply print the name, means this is outside the class definition, means I just declare this outside the class. Okay, here I just write cout, and which is here I just write, and then I just write car name is, and then I just simply write car BMW here. Okay, and just close this code here. Now I just turn to the main function, so integer main, and then here I just write car which is equal to, and car which is equal to I just write obj1. So I just create an object here, so it's car, I just create an object to this car, and then here I just write obj1 dot BMW. So I think BMW is capital one, so BMW, and then which is equal to, here I just write the name of the BMW is BMW. Okay, and then obj1 dot id which is equal to, so I just give it the model right here, so I just write 2018. Okay, or I just simply write BMW 18. Okay, now I just call the print name function. So obj1 dot print name functions mean like this print name function. Okay, so here I just write obj1 dot print name. So this is the method to call the print name function, and then cout which is end line. Okay, then I just call the print id function. So obj1 dot print id, and then here I just simply close with semicolon, and then I just write cout, not cout, I just write return, and the return is 0 right here. So run this code. So we have an error which is void car and then print name. Okay, so we have an error here. So here I just misprint the spelling with the print and then object number 1 and then object number 1. So I just build it again. So object number 1 and then print name. Okay, and now I just run this code. So you can see here the car name is BMW, so I just simply print the name here and then print the name which is car BMW and then create an object and print this object, and then BMW ID here is 18. Note that all the member functions defined inside the class definition are by default inline, but you can also make any non-class function inline by using keyword inline with them. Inline functions are actually functions which are copied anywhere during compilation, like preprocessor Marco, and so the overhead of the function is called reduced. So this is a simple example of the classes, access the classes member using function. If you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the public, protected and private access specifier in C++. So C++ provides 3 access specifiers which are public, protected and private. Let's just discuss the public first. The data members or the members functions which are declared as a public can be accessed anywhere in the program, means like this one. Okay, so we have the public data members, so we can access anywhere in the program. Okay, so within the same class or without the same class, without the class. Then we just go to the private. So data members or the members functions which are declared as private can be accessed within the same class only. For example, the private data members or the members functions can be accessed within the public members functions. Mean you just simply access these private data members in the public data members functions. Okay, in the same class. Then we just discussed about the protected. So protected data members are member functions which are declared as a protected can be accessed in the derived class only or within the same class. Means we are just taking example of the inheritance. We just discussed about the inheritance in our next lectures. So we just simply use protected in our inheritance, which are where we just create child class, parent class like this one, so that the protected work like within the same class or a derived class. Okay, let's just see the example of demonstrating use of public and private data members and the members function. Here, as you can see, I just copy this header files and then I just write the class name which is example. This is my class name here. Then I just write private, so private as a keyword, and then colon, and then here is I just write integer val, any variable you just want to give here. So this is the data members of the private access specifier, then is public, and here I just write public, and here I just declare the function. So I just write here void and initializer underscore variable. So I just initiate simply the val function right here. Okay, so integer v, and then close this code right here. So I just create integer, new integer in this function. Okay, so this is a simple, you just also call the parameters of the function. So void print underscore val. So I just simply write print underscore val. So I just create one other function with the print underscore val, and outside this class I just write function definition. So void and example right here, and then initiate underscore val. So I just simply call this functions here. Means I just simply create the scope resolution right here. So now afterwards I just go to the here I just write val and then integer v. Okay, and then here I just write val, which is equal to v. Okay, then I just create one another function or scope resolution right here, which is example, and then print underscore val. So I just print this function. First I just print this function, and now this function. Okay, now here I just write cout, which is val, means the function variable name, and then here I just write val, which is end line. Okay, now I just simply go to the integer main function. So here I just write int main, and then create an object here. So example, and example, which is ex here. Okay, so class, I just create the object to this class, which is ex name. So ex as a name dot, I just write initiate val, and the value here is 100, and then ex and print val here. So I just call this functions too and return 0. So I just run this code and check the output. So we have an error in example void example, and yes, here it's an example, and then I just misprint a spelling mistake here, and now I just run this code. So you can see here the value of that val is 100 right here. Okay, so in this example, variable val is private and accessing within the public member function. So initiate underscore val and public underscore val functions means the member function initiate val and print val are the public, and they access within the main function and outside of the class function with the help of class object, which is here I just create ex. Okay, now I just create one other example for the protected, and here I just write public private protected specifier 2.c++. Okay, so as I just told you that protected data members means protected class is you just simply use of this data member, or the member functions which are declared as a protected can be accessed in the derived class or within the same class. So here simply you just make a concept. We just discussed about that in our inheritance lecture, because this concept is very much using in inheritance. So this is example number 1, and here I write protected. So protected right here, and then here I write integer a. So that data member is only accessed within the class or a derived class. Okay, now I just access this with the help of derived class. So example number 2, and here I just write public and example number 1. Okay, so here I just access this class. Now I just create public, which is the function of void initiate underscore a. Okay, and then integer a. Okay, then here I just use keyword as this, and then here I just write a, which is equal to a. Okay, now I just write void print underscore a. So I just simply create print function, first initialization function and then print function. So cout, which is a, and then here I just write a and end line. Okay, now simply go to the main class, and then here I just write example number 2, which is ex. So here I just write example number 2, sorry, it's example number 1. So example number 1 as a ex class name,
and then I just create an object to it. So example of that object is here. I just write dot ex dot initiate a. Okay, and then here I just write 100. Sorry, 100. Okay, then ex dot print underscore a, and here I just write nothing because it will print nothing here, and then return 0. Okay, now first of all I just create a protected class here, means that data members will access only that class or in a derived class. So I just create one other class and access all the data members of that class in this class. So I just write public void initiate a, and then I just take this integer in this class and then use this keyword and a which is equal to a. Then I just create two functions name, which is print and the initiate. So here I just write print, and it will print only the result of that a. And then we just go to the main body, and here I just write example number 1.ex, create an object to this class, and then I just write object and dot operator, then initiate number a, and then return print the value of a. Now I just run this code, and here we have an error of misprint of that less than sign. And then here I just write ex dot initiate underscore. So here we have an error that there is no name with that one. Yes, I just did a little mistake right here, because this is example number 2, because we will access this class in the main body, because we cannot access the example number 1 class in this main body. So simply yes, and now I just run this code. So you can see the output of that one. So variable a is protected within the class, you can see here in the example number 1, and the example number 1 is a base class, means it's a parent class for example number 2, and example number 2 is example number 2 is inheriting from example number 1. So here a variable can be accessed within the member function of example number 2. So this is the logic of simply the parent and the child classes in this lecture. So if you find any other problem regarding this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the class constructor and the class destructor in C++. A class constructor is a special member function of a class that is executed whatever we create new object of the class. A constructor will have exact same name as the class name, and it does not have any return type at all, not even void. So constructor can be very useful for setting initial value for certain members of variables. Let's just see the coding example of that, and just copy the header files, and then here I just create a class of constructor which is the line. Okay, now the data members of that class here is public, and then here I write void which is set length. So set length here is I just write double which is length. Okay, now I just close this code here, and then double which is get length, and here I just define the type which is void, which means that return nothing. Now here I just declare the constructor. So constructor here is same as the name of the class. Okay, and now I just write private, then double which is length, and then I just close this class right here. Okay, now I just write line which is the scope resolution of line, which is the name of void. Okay, now here it will access the member function definition. So first I just define the member function including constructor. Okay, and then I just write cout, and the cout here it is object, and here I just write object is being created. Okay, and then end line. So here I just simply do the relational means scope resolution means here I just simply define the member of the function's definition including the constructor, and here I just define the constructor here, and it will print object is created here. Okay, then void line, and then here I just write set length. Okay, and the set length here is I just write double, which is length. Okay, and then I just write return length. Okay, so I just take the return of this length which is in private. Now I just go to the double line scope resolution, and then get length. First I just set length, now I just get length. So here I just simply write void, and that will return to us which is length. Okay, now main function. So integer main, and then I just write set the line length. So line dot first I just create line which is that one, so I just create an object to that. So line dot set length, and which is 6.0, and then cout which is I just write here length which is length of line. So this is string right here, and then here I just write line dot get length, and then end line. Okay, now return 0. So I just create the program execution right here, and you can see we have an error which is return, and it will give us the return which is length. So we have error which is in set length and then get length. Yes, here I just did a little mistake, which is length is equal to len. Okay, so here I just simply take this double as an integer too. It will set the length right here. Okay, now build and run. So you can see here first it will create an object with the help of line and the line. So it will create the constructor right here, and then the length of that object is 6. So it will only take 6 here. Okay, so this is the simple class constructor in C++. If you not understand that, please let me know. Now it's time to go to the class destructor. So a destructor is a special member function of a class that is executed whatever an object of its class goes out of the scope, or whatever the delete expression is applied to a pointer to the object of that class. A destructor will have exact same name as the class prefix within a tail like this one. Okay, you just simply this one. Okay, this is a symbol of that one. So, and it can neither return a value and nor can it take any parameter. Destructor can be very useful for releasing resources before coming out of the program, like close file and releasing the memories, etc. Now I just take an example of that. So simply copy that constructor example, and right here you can see I just simply define the header file, class name, constructor, and then public, which is set length, and then length here, and double, which is the get length here. So here I just create the constructor. So this is the constructor right here, and what is the destructor? So simple use this symbol right here, and then line, and then close this code. So this is the destructor. So this is a simply declaration of the destructor right here. So private, which is length, and then we just go to the scope resolution. So line which is equal to line, and void same like that one, our old example, and then void. Sorry, after that I just go to the destruct that example. So here I just write line, and then scope resolution, then that symbol, and here I just write line which is void. Okay, and here I just copy this, and here I just write deleted. Okay, the object is being deleted, and here it's a constructor, so it will create an object, and then it's a destructor, so it will delete an object. So now after that, void length which is set length, and double length here, and then length which is equal to length. Now double line which is get length, and same like our old code, and here this is also same like our old code, but simply we just add the destructor in this code with the help of that code. Okay, so now I just run this code. So we have an error right here, which is yes, this is the line as a class name. Now I just run. You can see here, first constructor print the object has being created, then it will print the length right here. Okay, then it will delete the object with the help of destructor. You can see here, first it will create this line, then a statement will directly go through the line of means the length of the line, and then it will go back to the destructor, and that will delete the object right here. So this is a simple example of the constructor and the destructor in C++. If you find any of the problem regarding this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to work with the copy constructor in C++, and we are just demonstrate our that example with means our like old examples. Okay, so what is a copy constructor? So a copy constructor is a member function which initialize an object using another object of the same class. A copy constructor has the following general function of the prototype, like class name, and then it will use construct as a keyword, then class name, and then use AND operator to hold the address. So here I just write O underscore object. Okay, simply this is the syntax to write this constructor. Okay, now we just go to the coding example. So here a copy constructor is a constructor which create an object by initializing it, I just told you that, with an object of the same class, so which has been created previously. So the copy constructor is used to initialize one object from another same type, and the copy an object to pass it as an arguments to a function, and copy an object to return it from a function. So if a copy constructor is not defined in the class, so the compiler itself define one, and if the class has pointer variables and has some dynamic memory allocation, then it is a must to have a copy constructor. Okay, let's just see the example of that how this copy constructor works. So first of all, the header files like here, and same our old example, it's a line as a class name, then the public and void set length, and here I just simply define void. Okay, now we just go to cancel that one, and here I just write line. So this is our constructor, so line which is length, and then here I just write the copy constructor, so line which is use construct as a keyword. Okay, and then line, and then AND operator to hold the address of that object, means it will copy the address of that object. So this is the copy constructor, and this is our destructor right here. Now we just go to the private, and here is simply I just write pointer, so integer static ptr, and then the members of definition including
functions right here. So the line which is equal to line, and the line is integer length here. Okay, then it will print like normal constructor. So normal constructor, I just write here allocating PTR, means allocating pointer. Okay, then here I just allocate the memory for the pointer. Okay, so PTR, which is equal to new integer, and then static PTR, which is equal to length. So here the pointer is allocate memory. So inside this class, so here, so now line, which is here, I just write copy constructor. So construct as a keyword, then line, and add object right here. And then here I just write, paste this, and here I just write copy constructor is allocating PTR, and simply copy that and paste it here. So here static PTR, and it will get the object dot PTR. Okay, so it will copy the value right here. Okay, now we just go to the destructor. So this is the constructor. Okay, so first I just copy this, and then this is the copy constructor. So now the destructor right here. So the destructor value is void here, means it will return nothing. And then here I just write freeing memory. Okay, and then it will delete the pointer. Use simply delete as a keyword for deleting the object, and then static PTR. Okay, then after this I just remove after this I just leave this get length here, and then I just write here that void and display, which is the line of display the line of object. And after that, so this void is return us PTR. Okay, and now here I write cout, which is length of line, and then here I write obj dot get length, and which is end line right here. Okay, now I just go to the main function of the program, and here I just write line, which is the line, and here I just write 20 as that value of that line, and then call this display function. Okay, so display function here, and then I will print the line of that here, means I will print the object of that in the display. So simply return, and now I just build this program, and here we have an error right here, which is delete, and I just write static PTR. So this is simply the PTR. Then we have an error in like there is no double involved in this, so that's why this is given error. And line dot get length, and which is void PTR, and it will return the PTR. Okay, yes, I just forget to declare the get length right here. So get length, and here I just simply correct this program, which is miss the print of that. So yes, we have an error again, because the get length here is void, and I'll recheck the program again. So get length, which is integer. Okay, so now I just run this code. Okay, so first of all, it will print the normal constructor allocating the PTR. You can see here. Then copy constructor allocating the PTR, and it will print the result of that, and then freeing the memory with the help of destructor. So this is a simple concept of the copy constructor in C++. If you find any of the problem regarding this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture you will learn to create friend function in C++ and see how we use them efficiently in our program. Friend function is one of the important concept of object-oriented programming is data hiding. For example, a non-member functions cannot access an object, private or protected. But sometimes this recursion may force programmer to write long and complex codes. So there is mechanism built in C++ programming to access private and protected data from non-member functions. So this is done using the friend functions or a friend class. So simply, there is a simple syntax of the friend functions to when you are just declaring. So you just simply write the class name, class, and then class name. So in the class name, you just simply write friend as a keyword, then return type of the friend function, return type, and then function name, and then the arguments of the functions. Okay, this is a simple declaration of the friend function. Now we just go to the coding example of that, and we just see how these friend functions work. So I just write hash include, and then istream using namespace std, and then here I just write class name, which is distance. Okay, so I just create a class which is the name of distance, and then here I just write private, and private here is I just write the data type, which is integer and meter. Then public, and the public here is I just write distance. So distance is my class name, and then I just close this distance right here, and then I just write meter, which is 0. Okay, now I just declare here a friend functions to take this distance. Okay, so friend as a keyword here, and integer, which is add 5, and now here I just write distance. Okay, so distance right here. Now after that, I just simply define the function definition, means friend function definition. So add 5. So you can see here this is a friend function, the return type, and then the function name. So friend function, and then here I write distance, which is d, create an arguments and to the distance d right here, and then d dot meter, which is plus is equal to 5. Okay, so it will access the private data from non-member function. So you can see here I will access the private data member functions with the help of this friend function, and then return d dot meter. Okay, now integer main, and then the distance d. Okay, now cout, which is distance, cout, which will print the distance right here, and then I just write add 5, and where the object here is d. Okay, and then return 0. Build the program, and we have an error right here, which is distance, and then the meter, here it's a meter.
Okay, so now I just run it again, and now you can see here the distance is 5 here. So we will get the private data from the non-member functions. Okay, so friend function is also called the non-member functions. So a friend function can be a function or a function template or the member of the function or a class or the class template. Okay, so even through the prototype of the friend functions appeared in the class definition, and the friends are not the member of the function, remember that. So to declare a friend functions as a friend of a class, so predicate the function prototype in the class definition. So we have the keyword which is the friend. So same like that, so I just simply create the class, then private, so here the data members of that private, and then access private access specifier, and then the public, and then the data member. So here I just create a friend function, then create the means after that I just create the friend function definition right here, and then the main function. So I just call this distance in the main function. So here we have the result which is 5 right here. Okay, so this is a simple program to write to define the friend functions or to working with the friend functions. If you find any of the problem regarding to this lecture, please let me know. So I think I just not define that all code right here. So here we have add 5 friend functions. Okay, is to declare inside the distance of the class. So you can see here I just define this add 5 inside the distance class. So private data, which is the meter right here, can be accessed from the function from this function. So all through this entire example gave you an idea about the concept of the friend function. So it does not show any meaningful use. A more meaningful use would to when you need to operate an object of 2 different classes. That is when the friend functions can be very helpful. So you can definitely operate on 2 objects of different classes without using the friend function, but the program will not be along complex and hard to understand. So this is a simple explanation of that example. So if you find any of the problem, please let me know. Thanks for watching this lecture.
Welcome to this lecture. In this lecture, we are just going to talking about the inline function in C++. As you studied in C that we have used Markov function as an optimization technique used by the compiler to reduce the execution time, etc. So a question come in the mind that was there in C++ for that, and what all better way? Inline function is introduced, which is optimized technique used by the compiler especially to reduce the execution time. We will cover in this lecture that why, how, and when we just use inline function and what is inline function. So how to make what is the inline function? The inline function here is the inline functions are in C++ enhancement features to increase the execution of the program. Function can be instructed by the compiler to make them inline, so that compiler can replace those function definition however those are being called. Compiler replace the definition of inline function at compile time instead of referring function's definition all runtime. Note that this is just a suggestion to compile to make the function inline if function is big in terms of execution instruction, etc. Then the compiler can ignore the inline request and treat the function as a normal function. Let's just see how to make the inline function. To make the inline function as inline, start with definition with the keyword which is inline. Like we have the class name A, and then I just write public, then inline. So inline is our key here, keyword here, and then integer add, and I just define this function's parameters is integer A and integers B. Okay, let's close this code right here, and then you just simply define the return type right here, like a plus b or a minus b. Okay, so this means that this is the inline functions here, and how to declare the inline function with the help of inline keyword. So why to use this inline functions? In many places, we create the functions of small work functionality with certain example and less number of execution instructions. Imagine their calling overhead each time they are being called by the caller. When a normal functions called instruction and encountered, the program stored the memory address of the instructions immediately following the functions called statements. Load the functions being called into the memory copied argument, and values jump to the memory locations of the called functions. So the execution, the program code store the return value of the functions and then jump back to the address of the instruction that we saved just before execution called function. So too much runtime overhead here. So what is the purpose of inline functions? So it speed up our program by avoiding the function overheat. Okay, then it save overheat of the variable push pop and stack when function is calling happened, and it save overhead of run call from a function, and it increase locality of reference by utilizing the instruction cache. So there is a point that when to use this inline functions. So use inline function when performance is needed. When you just need fast performance, so just use inline function, and use inline function of over macros, and then prefer to use inline keyword outside the class within the function's definition to hide the implementation detail. Let's just come to the example of that inline function. So here I just write that hash include and put out stream. Okay, and then using namespace std. Okay, now here I just define as a keyword of inline function, which is inline, and integer max. So this is our function name right here. Then integer x and integer y. So these are the parameters of our function, and then here I just define the return type, that x which is greater than y, and x and y. X and y. Okay, now just go to the function's main body right here, and then integer main. So remember that we just use these functions to increase the performance. So cout, and then here I just write max, which is 20 and 10. Okay, and then here I just write max is 20 and 10. Okay, so maximum r means 12, 20 is greater than 10. Then end line. Okay, copy this code, paste it here and here. So maximum right here is 200, 0 and 200, then 0 and 200. Okay, now 10 and 1000, then 10 and 1000. Okay, so this is a simple declaration what I just write here, that 20 is greater than 10, 0 is greater than 20, 200, and the maximum, it will take only the maximum values from here. Okay, so now return, and the return right here is 0. So let's just check the output. So there is return value which is 0, and now I just run this code. So you can see here with the help of this inline function, I just declared the max here, then integer x and integer y. So integer x is greater than integer y, so I just declared these all values right here for the maximum function. So it will take only the maximum values from these all values. So you can see here, this is with the help of functions, inline functions. Okay, a function's definition in the class definition in an inline functions definition even without the use of inline specifier. Remember that. So there's some key point that you can note with this inline function. So it's just a suggestions, not conclusions. Okay, so compiler may or may not inline the function you mark as inline. Means compiler will take or not take these functions if you mark as an inline. Okay, it may also reuse the inline functions not marked as an inline at the compiler or liking time. Inline works like a copy-paste control by the compiler, which is quite different from a preprocessor directories or preprocessor macro. The macro will be forkably inlined with pull out pollute. All the namespace and code won't be easy to debug. Okay, the most of the compiler would do inline for recursive function, but some compiler provide program Microsoft C++ compiler inline recursion on, and once called also control its limit in inline depth. So this is a simple inline function in C++. If you find any of the problem regarding this lecture, please let me know. And thanks for watching this lecture.
Welcome to this lecture, and in this lecture we are going to talking about this pointer in C++. Every object in C++ has access to its own address through an important pointer called this pointer. The this pointer is an implicit parameter to all member functions. Therefore, inside a member function, this may be also used to refer to the invoke object. Friend functions do not have a this pointer. Remember that. Because friends are not member of a class, only members functions have a this pointer. Okay, let's just see the coding example of this pointer. And here I just write hash include an iStream. Then using namespace std. Okay, now here I just define the class of test, which is a local variable is same as a member name. Here I just create the local variable name, which is the same as the member's name. Okay, now here I just write private, and then private, and then here I just write integer x. Now public, and then here I just define the function which is set x, and the parameters of the functions like integer x right here. Now I just use this dot this and then this and then x, which is equal to x. So this pointer is used to retrieve the object's x hidden by the local variable x. So the x object hidden in this one like integer x right here. Okay, now after that I just write void print and cout. Cout here is x, which is equal to, I just write x and end line. Okay, so our this class work is complete here. So integer main, and then I just create the test object, test class name here, and then test object is tst. Okay, so this is my class name and this is the object name. Then integer x, and give it the value to my x, which is 30, and then tst dot set x, and which is set x right, and then which is the value of x, and then tst dot print, and the print is simply the value right here, and then return, which is 0. Okay, now I just run this code, and here we have an error which is using namespace and hash include, so test is not declared. Yes, and then compile it again. So we have an error again. So here I think I just missed the parenthesis right here, and run again and run this code. So you can see here with the help of this pointer, it will give us the result of x which is equal to 30. So for class x, the type of the pointer is x constant. Also if the member function of the x is declared as a constant, then the type of the pointer is constant x and the constant. So here in this example, we just create a class of test, then private and hidden function, data types which are x, then public. So I just set make a function name which is set x, and then define the parameters which is integer x. So I just take this x with the help of this and x which is equal to x. So this is the pointer which is used to retrieve the object of x which is hidden by the local variable. You can see here this object is hidden by the local variables. Okay, and then void print and see out x which is equal to, and it will print the result of that x. And then I just make a class name right here, and then after that I just create an object, and then I just write integer x which is equal to 30, and then object test which is dot text x, and it will print the value and return 0. So this is give us simply the result of x which is equal to 30, because I just defined x which is equal to 30 right here. So if you find any of the problem regarding this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and this is an introductory lecture of inheritance. So the mechanism by which one class acquires the property of another class, which is called inheritance. One of the most important concepts in object-oriented programming language is inheritance. Inheritance allows us to define a class in terms of another class, which makes it easier to create and maintain an application. So this also provides an opportunity of reuse the code functionality and fast implementation time. So we just go next. So arrange concept into an inheritance hierarchy. So concept at higher level are most general, and the concept at low level are most specific. So inheritance properties of concept at higher level, like you just see here that we have a parent class which is vehicle. Okay, then you just see another class which is wheeled vehicle, and then boat. Okay, so this is our parent class which is vehicle, then child class. And you can see here the properties of that vehicle class. We have the car and then bicycle. Okay, so these are the properties of that class, and this is parent, and it's derived, these child classes derived from this parent class. Okay, then we have the properties of car, which are 2-door car and 4-door car. Okay, so this is the simple hierarchy of the inheritance. Next, C++ and inheritance, the language mechanism by which one class acquires the property, data, and the operators of another class. First we have the base class. So the base class is being inheritance from, which is our super class, and you just also class this base class to the parent class. Then we have the derived class, which is also called the child class. Okay, so the derived class or the subclass, so this class is inheritance from, means this class inherit from this base class. Okay, so the advantages of inheritance: when a class inherits from another class, there are 3 benefits. You can reuse the method and the data of existing class, and you can extend the use class by adding new data and the new method. then you can modify the existing class by overloading its method with your own implementations. You can see the diagram of deriving one class from another. As you can see here, we have this class which is QType object, and this is the private data members of this base class. Then we just access these all data members from this class. So this is simply the deriving one class from another class, you can see here. Okay, then we just see inheritance and accessibility. So a class inherit that behavior of another class, and instance it is same way. Inheritance does not mean inheritance access to another class, which is the private members. What does a child class have? An object of derived class has all members defined in the child class and the all members declared in the parent class. An object of derived class can be used all the public members defined in the child class and a public members defined in the parent class. The rules of building a class hierarchy, which is a derived class, are a special case of the base class. A derived class can also serve as the base class of a new class, and there is no limit on the depth of inheritance allowed in C++, as far as it is within the limit of your compiler. It is possible for a class to be an base class for more than one derived class. Remember that. Static versus dynamic binding. So static binding is the determination of which method to call at compile time, and the dynamic binding the determination of which method to call at the runtime. We have the multiple inheritance, which is derived class cannot inherit from more than one base class. Okay, so you can see here, this is our parent class and this is child to this parent, and we have the class name X, Y and Z. Okay, now this class is inherit from this class, mean this is a child and this is a parent. If we create third class here, which is the Z class, so our this class will be parent and this class will be child to it. Okay, so child parent and this is child to this class parent. Okay, so if you find any of the problem regarding with this lecture, please let me know. And this is the multiple inheritance, and if you find any of the problem regarding with this multiple inheritance, please let me know. And thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the based and the derived classes in C++. Okay, when creating a class, instead of writing completely new data members and the member functions, the programmer can designate that the new class should inherit the member of an existing class. The existing class is called the base class, and the new class is referred to be the derived class. So a class can be derived from more than one class, which means that it can inherit the data and the function from the multiple base classes. So to define a derived class, we use the class derivation list to specify the base class. So a derivation list means means one or more base class, and it has the form like we have the class which is derived class, and then access specifier, and then based class. Okay, so where access specifier is one of the public, protected or the private, and the base class is the name of the previously defined class. If the access specifier is not used, then it's provide a default. Let's just see the example. So we have the base class here like name, shape. So shape name, this class is our based class. So here I just write public and then void, which is set width, where integer w is our parameters, and then width here is equal to w. Okay, so this is w. Now here I just write void set height, and integer h here is our height parameters, and then width, which is equal to height which is equal to h. So this is our based class, or you can see this is our parent class. Now class rectangle, so our shape is rectangle which is inherited from our base class. Then access specifier which is a public, and then shape. So shape our base class right here. So I just told you that derived class, which is the colon sign and then access specifier and the base class name, and the access specifier will be the public, protected, and the private, any of it. Now here I just write that protected, which is integer width and integer height. So I just protect these height and the width, okay, which is the abstract, means you can hide this information of the width and height in the base class. Okay, so now public, which is integer get area, and then I just write that it will return width and height. Okay, so area formula is width multiplied by height. Now I just go to the main function, and the main function right here is, I just write rectangle. So I think rectangle spelling is wrong here, so I just simply write rect, and then rect, which is dot set height, and the height is 6, and rectangle dot set width, and the width here is 10. Okay, now see out and total area, so that will print the object of rectangle, which is the total area. Okay, and dot, I just write get area, and then end line. Okay, now return 0. Build and compile. So you can see here it is compiling, and now you can see here it calculate the width and the height, and the total area is 60 here. So first of all, I just define the base class, which is the name of shape, then specifier, which is public void, and set the width, then variable to the width, and then set the height, then variable to the height. Then I just hide the functionality of these two. Okay, and then this is the syntax that how you access the parent class with the help of derived class. So class rectangle, and then specifier and the base class name, and then the value to it, and then at the last I just go to the main function and rectangle, and then create an object to this class, and then rectangle, so it will get the height and the width of the base class, and then print the total area of that rectangle class. So if you find any of the problem regarding this base class inheritance, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture you will learn about different models of inheritance in C++, which are the multiple, multi-level, and hierarchical inheritance. So let's just start. So inheritance is one of the core features of an object-oriented programming language. So it allows software developer to derive a new class from the existing class. The derived class inherits the feature of the base class. Let's just see the multi-level inheritance. Okay, so I just write multilevel.c++. Okay, now in this programming not only you can derive a class from the base class, but you can also derive a class from the derived class. So it is a form of inheritance which is known as multi-level inheritance. Let us suppose we have
like class name A, and then specifiers like public, and I just write the function name void, and then display. Okay, and then it will print cout, which is base class content. Okay, close this code, and then we'll go to the class B. So class B is our second class, which is derived from this class, means from parent class. So here I just write public A. Okay, and then class C, which is derived from public class B. Okay, and then I just write integer main. Okay, so C, and here I just write C and obj to create the object to this class, and then obj dot display the members of our this class A and return 0. So in this program, class C, which derived from class B, which is the derived class of the class A. The object of this class C is defined in the main function. When the display function is called display, so in this class A is executed at base, there is no display function in C++ and C and class B. The compiler first look the display, so function in the class C, since the functions does not exist here. It's look for the function in the class B, and as C is the derived from B, so the function also does not exist the class B, so the compiler look for the class A as B is derived from A. If display function exists in the C, the compiler override the display of the class A because of method function overriding. Let's just see the output of this code, and as you can see here, it will print us the base content of this class A. Okay, base class content. Now we just go to the multiple inheritance. In C++ programming, a class can be derived from more than one parent. For example, class A, we have, let's suppose class A, which is like shape, and it's derived from the base class of rectangle and you just see triangle. It makes sense because base class shape is a rectangle as well as triangle. And we just go to this class, and I just copy the code of that, and here I just write shape, which is the void set width and then set height, and then it is protected with integer width and the height. So here I just define another base class because this is the multiple inheritance. So class, which is the base of, here I just write paint cost. Okay, so one other class right here. So right here public, and then integer get cost and integer area. Okay, now return area, and the cost here is 70. Okay, then we just go to the rectangle class, and it will derive from the shape class, and then I just write public and paint cost class right here. So this class derived from this and this, and then public dot get area and get width, height and width. You can see here it gives us a return value, and then rectangle rect right here. So integer, I just write here integer area, and then rectangle dot set width and the set height right here. So after that I just write area, which is equal to rectangle, and then I just write get area. Okay, now print that total area dot rectangle dot get area, and then I just print the total cost. So cout here is, I just write
that total cost, and then here I write rectangle dot get cost, and the cost of that is area, which is equal to end line. Okay, now I just check the output for that. So we have an error right here, which is to get area, which is rectangle dot get area, and then yes, miss the semicolon right here. And you can see here, first it will get the area, which is 60, and the cost is 4200 of 4200, which is the print cost right here. So let's just see the hierarchical inheritance, and we just not working with the hierarchical inheritance of the real life example. So we just simply write hierarchical dot C++. So if you have more than one class in the inheritance, so from the base class, it's known as hierarchical inheritance. In hierarchical inheritance, all features that are common in the base class are including in the base class. So let's just see simply the syntax of that class, which is class, and then you have the base class. Okay, then class first and underscore derived class, which is inherit from the base class. Sorry, it's inheritance from the base class, and that one. Then we have second class, which is also inherited from the base class, and then we have third class, which is also inherited from the base class. So all the classes inheritance from the base class, it's also called hierarchical inheritance. So if you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the function overloading in C++. Two or more functions have same name but different argument, as we know as overloaded function. So in this lecture you will learn more about the functions overloading. So let's see, we have void, and I'll just write here void same name function, which is integer a. Then we have integer same name function, which is float a, and then void same name function, which is integer a, and then double b. So we have same name functions, but we have the different arguments here. So functions refers to a segment that group code to perform a specific task. In C++ programming, two functions can have same name if numbers or types of argument passed are different. These functions have different numbers or type, or both of parameters are known as overloaded functions. Let us see that we have integer test, and then integer test, which is the parameter, which is a. Then here I just write float test, which is a parameter of double a, and then we have the integer test, which is integer a and double b, like this one. Okay, like this one. So here we have four functions are overloaded functions because of argument passed to these functions are different. You can see here test, 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 and test. And here we have three functions overloaded. Okay. Notice that the return types of all these four functions are not same. You can see here return types integer, double, integer, and double. And the overloaded functions may not have
different return type, but it should have different arguments. You can see here a, integer a, double a, integer a, and double a. Okay, so double b. So let's see the example of that functions overloaded. So we have void display, same function with different return type. Then I just write void display and void display. So here I just write float, and then integer and float. Okay, three functions name with different return types. Now integer main. Okay, so integer main right here, which is the integer a and which is equal to 5. Then float b, which is equal to 5.6. Okay, sorry, b which is equal to 5.6. And then we have the display functions right here, and the display functions, and I just passed the parameters or the arguments, which is a, then display, which is b, sorry, which is yes, b, and then display, which is a and b. Okay, and it is return 0. Now I'll just overload these functions here. Okay, now after that I just write void display, and the display here is integer variable, and now I just write cout, which is integer number, and this is integer number, and then variable, it will print only the variable, then end line. Okay, so you can see here that will print this integer variable. Copy this code for float and float for integer variable, and then float variable 2. So float variable 2 and integer variable 2 right here, and then it will print integer and then variable 2, and sorry, integer variable 1, and then float variable 2. And here I just write variable number 2, which is print float. Okay, and sorry, that will the variable. Okay, so it will print only the variable values in float. So variable 1 and then variable 2 right here. So here the display function is called 3 times different types of the numbers of the arguments. So the return types of all these functions are same but not necessary. Build this program, and we have an error right here, which is void display and integer variable, and here we have end line and then error redefining the void type of integer variable. Yes, I just write here float. Okay, now just run this code. So you can see here first number integer 5, float 5, integer number is 5, and then float number is 5. You can see here these functions run 3 times. So the return type of these functions are same but not necessary. So this is the function overloading in C++. If you find any other problem regarding this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the encapsulation in C++. Encapsulation is a process of combining data members and functions in a single unit called classes. This is to prevent the access of data directly. This access of them is provided through the functions of the class. It is one of the popular feature of object-oriented programming language that's help in data hiding. How encapsulation is achieved in a class? So make all data members private. This is first step. The second step is create public setter and getter function of each data members in such a way that the set function set the value of data members and get functions get the value of the data member. Let's just see the example of the encapsulation. Like here I just write hash include r stream and then using namespace. Then here I just create a class of encap, which means that encapsulation, and here I just write private. So this is a specifier which is the name of private, and here I just write num, integer num and character ch. Okay, since we have marked these data members private, any entity outside this class cannot access these data members directly. They have to use gather, getter and setter function. Then I just write public and which is integer get num, and here is define the constant as a keyword. So return which is num. So here getter functions to get the value of the data member. Since these functions are public, they can be accessed outside the class and thus provided the access to the data member through them. Okay, and now here I just write character get ch. Okay, so get num and get character, which is the functions here, and then here I just write constant. Okay, now return which is ch. Okay, now here I just write void set num, this function. Okay, integer num as a parameter, and then I just write this this num which is equal to num. Okay, so now here I am just going to create the functionality of the setter function that they are called for assigning the value to the private data member. Okay, and same like this one for void set ch method. Okay, so set ch. Okay, set num and then set ch. Here's write character ch, and then same like our old code, this ch which is equal to ch equal to ch. Okay, now I just go to the main function, so integer main, and then here I just write encap which is en as an object. So I just better to copy this encap as a class name. Okay, encap and cn, and then here I just write en dot set the value to this number or set the character to this number, which is a, and then en dot set num, and the numbers here are 200, and then cout which is en dot get num which is end line. Copy this code and paste it here, and here is write get ch, and then it will print the value of get ch. Return 0. Now I just check the output, and here it is running the code right now, and you can see here the output for this code. So at the initial step I just declare the header files and class name which is encap, and then class specifier which is private. So since we have marked these data members private and the entity outside this class cannot access these data members directly, so they have to use getter and the setter method. Okay, so that's why I just write get and the set method right here. Okay, then here I just define public as a specifier, and then these functions to get the value of the data members. Since these functions are public, so they can access outside the class.
thus provided the access to these members through them. So that's why I just write get numbers and return types here number, and then get ch, then getter set method, and then here I just define, so here I just define get method and then set method. So this is the encapsulation in C++. If you find any other problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the abstraction in C++. Abstraction is one of the feature of object-oriented programming where you show your relevant detail to the user and hide irrelevant details. For example, when you send an email to someone, you just click send and you get the success message. What actually happens when you click send? So how data is transmitted over the network to the recipient in hidden from you, because it is irrelevant to you. You just only have the access to the front end, that you just simply send the data and then you just get the message, which is success message. Now we just see the example of the abstraction in C++. So here you just see I just write header file hash include iostream, then using namespace which is the std. Okay, now here I just define the class for abstraction, so abt, and then I just define the specifier. So a specifier here is private. Now integer num and character ch. So by making these data members private, I have hidden them from outside world. These data members are not accessible outside the class. The only way to set and get their values is through the public function. Okay, so here I just define public and then void set values. So I just create a function name which is set values right here to get the values of these two. So integer n and then character c. Now here I just write num which is equal to n and then character which is equal to c. So I just define two data types right here, which is a num is equal to n and the character which is equal to c. Okay, now our abstraction is here. I just go to the integer main and then I just write here abt which is our class name, and then ab is our object name. So ab dot set values, and the values here is 100, and then I just write which is f. Okay, so 100 is our number value and then f is our character right here. Now ab dot get, so sorry, I just forget to define one other function which is void get values. Okay, and now here I just write cout which is number is, and then here I just print only the number and then end line. Now here I just write character is and then print character. C is small here, and now our code for this example is completed here, and I just run this code. So we have an error right here which is void get values and then the character c right here. So character which is equal to c. Yes, first I just define this get values function right here, so it will get the values of this function and then return 0. So I just did a little mistake here because I just already defined this character right here. So character which is ch is equal to c, and here too I just write ch. and now it is compiling and run this code. So you can see here I just get these two values. So here I just define the abstraction level. So the abstraction level of this class is in private. So I just make these two number and ch is private, and then access these members with public specifier, and then set means use two method, which is get method and set method. Okay, and then get these two values with the help of this object. So the major advantage of using this feature is that when the code involves and you need to make some adjustment in the code, then you only need to modify the high level class where you have declared the member as a private. Since one class is accessing these data members directly to you, do not need to change the low level, means user level class code. Imagine if you had made these data members public. If at some point you want to change the code, you would have to make the necessary adjustment to all the classes that are accessing the members directly. Two other advantages of data abstraction are making the application secure by making data private and avoiding the user level error that may corrupt the data. And this avoids code duplications and increase the code reusability. So this is a simple example of the abstractions and the abstraction class in C++. If you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the exception handling in C++. An exception handling is a problem that arises during the execution of a program. A C++ exception is a response to an exceptional circumstances that arise while a program is running, such as an attempt to divide it by 0. One of the advantage of C++ over C is exception handling. C++ provide following specialized keyword to this purpose, which is try and catch. So try keyword represent a block of code that can throw an exception, and catch represent a block of code that is executed when a particular exception is thrown. Or you just say that a try block identifies a block of code for which particular exceptions will be activated, or a catch program catch an exception with an exception handler at the place in the program where you want to handle the program, and which is used as the catch as a keyword. Okay, so why we need exception handling? So we just need this for separation of error handling code from natural code, and functions method are handle any exception what they choose, and grouping of error types, like in C++, both basic types and objects can be thrown as an exception when can create a hierarchy of exception, object, group, and exception in the user namespace or the class, categorize them and according to the types. Let's just see the example of that exception. I just define the header files right here, then main function, and inside the main function I just define integer a and integer b, then cout, which is enter two numbers. Okay, then cin, which is a and b. Okay, here I just define the exception, which is try. So try is if b is not equal to 0. So here I just define that like float, which is div, and div which is equal to float, and which is a divided by b. So if this condition is not true, so print this logic right here. Okay, then if div which is less than 0, so throw exception to
throw exception to E. So E is using for a keyword which is exception. So cout, which is A divided by B, which is equal to, I just write here div. Okay, now I just go to the else block, and here I just write throw exception B right here. Okay, now I just write catch for catching these exceptions, so integer E, and then I just write cout, which is, I just write here exception, which is divided by 0, and close this code here. Now catch it again, which is the character of st. So here I just create a new variable which is character st, and then catch the exception of, here I just write division is less than 1. Okay, and this is also for catch sts. Okay, and now I just write exception for catch, and then here I just execute unknown exception. Okay, so this is unknown exception here, and now return 0. Okay, so here in this example the program is demonstrate how exceptions are handled in C++. The program performs divisions operations only. You can see here this will perform divisions operations. Two numbers are entered by the user with the help of these cin. Okay, and if the divided is 0, means if these numbers are divided by 0, is less than divided by 0, then the division by 0 will causes exception. So that will cause then exceptions right here. Okay, so which is thrown into the catch block, and this exception will throw to the catch block, and if the answer is less than 0, then exception division is less than 1. So that exception will be executed right here. So all other exceptions are handled by the last catch blocks, which is thrown unknown exception. So let's just see the output, and we have an error right here which is the unknown exception, and yes, miss this print right here, and here it's in catch block, and that will return. So the error here is accepted declarations before this token, so I just remove this and this too, and then run this code. So you can see here enter two number 2 and 2. So you can see here divided it 0, 1. Now here I just write the result, which is like 9 and 0. So you can see here this exception is divided by 0, so it will give us the result right here. Okay, now one another -1 and then 10. So you can see here division is less than 1, so that will give me the result of that. So this is exception handling in C++. If you find any other problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the polymorphism in C++. Polymorphism is a feature of C object-oriented programming language that allows the object to behave differently in different conditions in C++. So we have two types of polymorphism, which is compile time polymorphism and runtime polymorphism. This is compile time polymorphism, which is also known as static or early binding, and the runtime polymorphism, so this is also known as the dynamic or late binding. So the keyword polymorphism means have many forms. Typically polymorphism occurs when there are hierarchy of classes and they are related by the inheritance. Let's just see the compile time polymorphism, and in this lecture we just totally consist of the compile time polymorphism. So functions overloading and operator overloading are preferred example of compile time polymorphism. So here we just go to the example of that. So here I just write hash include and then iostream. Okay, now using namespace std, and here I just write a class of add. Okay, then public and integer sum. Here I just write integer number 1 and integer number 2. Okay, this is the function name, which is integer sum, and then the parameters are integer number 1 and integer number 2. Now return type is number 1 plus number 2. Okay, so this is the return type. Now integer sum again, and here I just write integer number 1 and then integer number 2 and integer number 3. Okay, so take 3 integers, and that will also a function name, which is sum, and then return number 1 plus number 2 plus number 3. Okay, now I just go to the integer main. So here we have the add is a class name, so AD is the object of that class. Now cout, which is output, and here I just write AD dot sum. So that will call the first function right here, which is 10 and 50 as a value, and then end line. Now output 2, and which is add dot sum. So here I just write 20, 30 and 50. So that will call the second function right here. Okay, and return 0. So now I just run this code. So you can see here first output is 60 and another output is 2100. Okay, now you can see here that this example we have two functions with the same name but different numbers of argument based on how many parameters we pass during the functions called determines that which function is to be called here. This is why it is considered as an example of polymorphism, because in different conditions the output is different, you can see here, and since the call is determinant during compile time, that's why it is called compile time polymorphism. So if you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture you will learn about the C++ templates. You will learn to use the power of templates for generic programming. Templates are powerful features of C++ which allows you to write generic programs. In simple terms, you can create a single function or a class to work with different data types using templates. Templates are often used in larger code based for the purpose of code reusability and flexibility of the program. We have the two concepts in the templates, which are the functions templates and the class templates. The functions template, a function template work in a similar to a normal functions with one key difference. So this lecture is totally based on the function template. So a single functions template can work with different data type at once, but a single normal functions can only work with one set of data types. Normally, if you need to perform identical operations on two or more types of data, you can use functions overloading to create two functions with the required functions declaration. However, a better approach would be to use function template because you can perform the same task writing less and maintainable code. Let's just see how to declare a function template. To declaring a function template, you just need template as a keyword, and then class, and any class you just write class T, and then T, and you just write some functions right here, and then T arguments. Okay, and then start your code right here. So the template is the keyword here, and the parameters inside these parentheses is the parameters. Okay, let's just see the example of this template functions right here. I just copy this code, and here I just write template as a keyword, and then class, which is T. So here it's a template function. So T, and here I just write large. So large is our function name right here. So I just pass the parameters. So T and 1, sorry, T is a capital here, so T and 1, and T and 2. Okay, and it will return us n1, which is greater than n2. Okay, and n1 and n2. So this is our function here. Now I just write integer main function, which is int I1 and then I2. Now float F1, so float F1 and then F2, and characters C1 and C2. Now C out here, I just write enter to integer. Okay, and here is write end line. Okay, now Cn, which is I1 and I2. Now here is write C out, which is enter to float point numbers. Okay, and that will Cin, which is F1 and F2. Okay, now I just write this for the characters. So after that I just write enter two characters, character, and then this is C1 and C2. Okay, now here I just write C out, which is the large function name here, which will print I1 and I2. Okay, and that will I just write here is integer and end line. Now same as a field like here and here. So this is F1 and the F1, and here is write float, and this is C2 and C1 and C2, and this is character. Okay, now return 0. So I just check the output. So we have an error right here, which is the token error, and now built again. So we have an error right here. Okay, and this is the large, and I1, sorry, this is I1 and then I2, and this is an integer and large, and sorry, I just missed
make a little mistake right here and build again. So yes, okay, and yes, our program. So enter two integers. So I just write 5, 10, then two float 5.0, 10 points, sorry, 10 is a float, so I just simply write 10 here. Characters are k and k, so k is characters area, as you can see here. So in this program, a function's template large is defined that accept two arguments, which is n1 and n2 right here. You can see here n1 and n2 right here. So n1 and n2 is a data type of t, which is t is signifies that arguments can be of any data type. Large functions return the large amongst the two argument using the template conditional operator. So you can see here this is template conditional operator. Okay, inside the main function, variables of three different data types, float, character and integer, are declared. The variable are then passed to the large functions as the normal function. During runtime, when an integer is passed to the template functions, compiler knows it has generate a large function to accept the int argument and does so. Similarly, when floating data and character data are passed, it known as the argument data types and generate a large functions accordingly. This way, using a single functions template, replace three identical normal functions and made your code maintainable. If you find any of the problem regarding to this code or regarding to this lecture, please let me know, and thanks for watching this lecture.
Welcome to this lecture. In this lecture, we are going to be learn about the recursion in C++. When method or a function is called within the same method or a function is called recursion. The method which calls same method, it's called recursive method. In other words, when a method call itself, then that method it's called recursive method. Recursive methods are very useful to solve many mathematical problems, like to calculate the factorial of a number and generating the Fibonacci series, etc. The advantages of recursion is method calling related information will be maintained by recursion, and stack evaluation will be take place by using the recursion. In inf, infix, prefix, postfix notation will be evaluated by using the recursion. What are the disadvantages? It is very slow process due to stack overlapping. Recursive program can create stack overflow, and recursive method can create as a loop. Now we see the example of this recursive method using the factorial numbers. And as you can see, I just write here the libraries of hash include iostream and using name space std. And then here I just define a method which is factorial and integer. Now int n and cout, which is enter a number to find a factorial. Okay, and here I just close this code, and then cn, which is n. Now I write cout, which is factorial of, and then n, and then here I just write is equal to. So is equal to is this function name, which is factorial. So I just pass a parameter which is n. Then return 0. Now integer factorial and integer n, and then if n is greater than n,
So return n steric factorial, which is n minus 1. So this is a factorial formula, and go to the else condition. So else is return 1. Now just execute this, and you can see here 20. So factorial of 20 is minus 21 and up to this number. Execute it again, and 2. So the factorial of 2 is 2. So as we look on the factorial formula, so I just take a function name here, factorial, and which is the integer n as a parameters. And if this condition means n minus 1 is true, so it will give us the result as a factorial. Otherwise, it will give us a return 1. Now, we see how we call this program as a recursive. So you can see here, I have a function name, which is the recursive function. Then in the main body, you can see here, I just call the function as a parameter. So here I just call this function. So it is the recursive function what I called here. So this is also the recursion, and the recursion is if n is greater than 1, and then it is the result of n steric factorial n minus 1. Suppose that we have the number 3 in this n. Okay, so factorial function tests the expressions inside if else statement. Means if statement factorial function tests the expressions while it is true, means this function is true. The return n steric factorial n minus 1 statement execute when called the second factorial functions, and the argument passed is num minus 1, which is 3. Means this our value n is 3 here. So it will give us the result of this value. So this is a simple example of the recursion in C++. Thanks for watching this lecture. See you in next lecture.
Welcome to this lecture. In this lecture, we are going to talking about the understanding of the basic file handling in C++. Files are used to store data in our storage devices, which is permanently. File handles provide a mechanism to store the output of a program in a file and to perform the various operations on it. Let's just suppose we have hash include, this is include, and iostream. This is also a streaming, or you may say this is also a stream in a abstraction that represent a device, or that will represent a library of C++. Let's just suppose a device on which operations of input and output are performed. You can see this is the input-output operations of for streaming. So as iStream can be represented as a source or destination of character of indefined length depending on its usage. Here in C++, we have a set of file handling methods. These include ifstream and offstream, and you may say you can also say that fstream also. We have ifstream, onstream, and fstream right here. Sorry, ifstream, offstream, and fstream right here. These are, you may say, these classes are derived from the fstream base class and from the corresponding iostream class. So this is the iostream class, which is the base class right here. So these classes designed to manage the disk files and declared in fstream, and therefore we must include fstream, and you may say that therefore we must include it file in any
program that use files. Let's just go to the coding example of this file handling and see how we open the file. Here a function is using to open the file like open, and after that users define the functions here. Generally the first operation performed on that object of one of these classes is associated it a read file or real file. It produce is known to open a file. We can open a file using any one of the following method, like first is bypassing the file name of the constructor and the time of the object creation. Secondly, we are just using the open function what I just declare right here. Okay, so let's just see we have void open function, and then I just write construct right here, and then character set of static file name you just write here, and then iOS and open mode which is mode. Here the first argument of the open function define the number and the format of the file with the address of the file, and the second argument represent the mode in which the file has to be opened. Like here I just define in, out and binary method right here. This is the binary. So in open the file to read default is if stream. Out open the file is to write default for the off stream, and the binary opens the file in binary mode. Remember that. After that you are just declaring the modes like ab, 8 and non-create and no replace. We have another example right here like fstream, okay, which is equal to new file, and then new file dot open, and then here is write new file which is dot text simple file. I just write here text io stream, then I just write out. So what is the out mode is used for? Out mode is used for the file to write default for the off stream. So as you can see here I just simply set the example right here. So in this example we have the new file right here which is the object. So this is our object right here. Okay, so this is the object of fstream. Okay, and as we know fstream is a class, so we need to create an object of this class to use it member functions. So we can create a new file object and call the open function. You can see I just call the open function right here. Here we use out mode that allow us to open the file to write in it. Okay, we use the default modes right here, like here I just go to out and then I just write iOS and app. We have open modes right here which is if stream, iOS out and then iOS app right here. You just also define like iOS in. Okay, so this is out and you can also define in right here. So as you can see in this example right here I just add iOS and app right here. So this is the input mode and the appended mode are combined with represent and it represent the file is opening for writing and appending the output at the end. As soon as the program is terminated, the memory is raised and free up. The memory allocates and close the files which are open, but it is better to use the close function to close the open file after use it the file. So this is a simple explanation of this program, that how the file handling works and how we create
the file handle with this method. Hope so you understand now with a very basic example of this file handling method. In next lecture, we will create the file and we will start working on our this text file. Thanks for watching. See you in next lecture. Welcome back to this lecture, guys. And in this lecture, we will start working on our last lecture. We are just creating the new files right here. So in this lecture, we will go through the file which is creating the text file. Here, I just define hash include iStream, and then I just define hash include, and then f stream. So I just told you simple why this f stream work and how this f stream work. So the main reason of the f stream is the stream. This is the stream class which can be used for both read and write form. Like you just do the editing and read also with help of f stream. Now just come back to the example, and here I just defining using namespaces which is std. Okay, now here I just define integer main function, and then I just write f stream, and f stream here is which is equal to new file or new file. Then here I just write new underscore file dot open. So I just simply open the new file right here, which is new underscore file and which is iOS out. Simple code right here. Then I just write if which is not new underscore file. Okay, I will explain this later. And then here I just write cout which is file creation failed. Okay, so this file creation is failed right here. If this is not equal to the new file, remember that. Then else we will go to cout and I just write new file is created. If this file is match with this file, so that file says that the file is created, the file is failed. And if this is the true file which is matched with new file, so it will go through the else statement and that will say the new file is created right here. Now I write new underscore file dot close, and this is our last step which is closing the file. Now return 0. I just remove this and check the output. So you can see here, first thing, this file is created. Let's just explain this program right here. In this program, as we see, this is our first file what we created an object to the class fstream right here. So this is the fstream class and its name is the new file. Then we apply the open function. You can see we apply the open function on our new file, this one, and we gave the name of the file which is new file to the new file we wish to create, and we set the mode to out which allow us to write in our file. You can see, and we use a if statement right here to find the file already exists or not. If it does not exist, then it will go to print that file creation is failed. or it will gonna create a new file and it will print the file. New file is created right here. This is a very simple example that how we are just creating the new file right here or not. So hope so you understand now, and if you not understand, then please let me know, and thanks for watching this lecture. Hello and welcome back to this lecture. In this lecture we will go through our old example and we will make this example in next step, which is writing to a file with the help of file handling. Let's just see. We are creating this all code, which is for reading the file, you may say, or just creating the file. Okay, now in this step we are just writing the file also. As you can see, we are just creating the new files here, then outstream, and then if file is created, so that will this file is not available with the name of new underscore file, so that will say that the file creation failed. Or if this file is created with new file, so that will show us the message of the file is created. Now we go to the next step, and here I just write that new file here, and the new file which is, I just write here hello C++. Okay, so I just write this hello C++ in the new file. Okay, hope so you understand now. And after this I just close this, remove this close right here, and then I just write this new underscore file and dot close right here. Okay, now let's just see, and we are just going to run this program again, and it shows that your new file is created right here. Let's just see, is new file is created right here or not. So this our new file is available right here, and we just open here. You can see it is edited with hello C++. Go to the example and you can see this is hello C++. So I am just going to explain this program. So here, as you can see, first we just create a new file in our last lecture with the name of new file. Then here we just create a new file, and then I said that write hello.c++. This is our open function right here. Since we want to send the output to the file, so we used iOS, which is out, as we given in this program. Information is typed inside this new file right here, which is in double quotations mark, and you may use the output statement sign. Okay, hope so you understand now with this example. If you not, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the data structures in C++. The data structure can be defined as an organized collection of the data that helps a program to access data efficiently and rapidly, so that the entire program can function in an efficient manner. As you can see on your screen, that the need for the data structures. I just told you that data structure is an organized form of data, which is a more efficient for the programs, and which is used for the more powerful computers and more complex applications. Data structure is also a collection of the data to the application. We just see the organizing data. An organization for a collection of record can be searched, processed in any other or modified way. The choice of data structure and algorithms can make the difference between a program running in a few seconds or many days. Let's just see an example that a person who are making a bank account. At the first day, he do make a bank account, he do transaction, and at the same day he close the account. This is a simple example that how a data structure work. As first stage, he make the account, he do transactions, and he close this account. Here a data structure is needed to check the data of the customer, to check the transaction, and if he want to close the account, so he will check the closing of the account here. So data structure is used for that purpose. We know that in a programming world, a data is a entire, or maybe you say that this is the center of everything, which is revolves around the data. We need to do all data operations including storing, searching, sorting, organizing, and accessing the data efficiently, and only then our program can succeed. You can see the efficiency of the data structure right here, that our data structure is more efficient. A solution is said to be efficient if it is solve the problem within its resources and constraints. Why we see data structures are more efficient? Because it's take less space and less time. The less space and less time means in less time you will make more softwares. The productivity is increase right here. The cost of a solution is the amount of resources that the solution are consumes. Let's just see the space. Here we have a stack. We will learn about the stack in next upcoming lectures, and in a same lecture this is the stack or queue. This is a queue and this is the stack. You see, this is the stack. Stack and queue both are using for the data structure. Let's just see, we have U, A, B, C, D numbers are here, and our one field are, or two fields are, or three fields are empty. Okay, so these are our indexing, like 1, 2, indexing start from 0, 1, 2, 3, 4, 5, 6, and 7. You can see if you want to allocate the memory to the U, let's just see, I just start from 200, so that will be the 201, 202, 203, 204, and these spaces are empty. So data structure will be leave these spaces and take only the memory location of these. This is just a called data structure. So same like a stack right here. As I just told you that data structure is the most efficient and less memory consuming. So that's why the programmer are liking the data structure more than a structural programming or a functional programming. So selecting a data structure, so analyze the problem to determine the resources and the constants a solution must meet the data structure. Determine the basic operations that must be supported. Quantify the resource constant of each operations. Selecting the data structure that best meet up the requirements. Some questions to ask about the data structure. Are all data structure inserted into a data structure at the beginning? No. At the beginning, there are not all data structures are inserted, because at the beginning we just not need a complex applications. Interspersed with other operations? No. Can data be deleted? Yes, you can delete the data. Are all data processed in some well-defined order, or is a random access allowed? Yes, it is allowed. Let's just go to the one example. For example, we have a student right here. So I just represent a student as the STD. So that can have the following details, like he have roll number, name, age, class, and grade. In name, he have more two fields, which is first name and last name. Here see the logic. We have the data here, group items here. We have to save the records of all these datas. You can see we have to save all the record in student of all these data. We have the entities right here. We have the attributes or fields right here. And we will make the student files right here. For that purpose, we need the data structure. In data, it is the elementary value. Like as you can see here in the figure, like student roll number, name and age can be a data. We have the group items as you can see here, which is first and last name. We have the entire record of the data, which is roll number, name, age, class, grade, etc. We have the attributes and the properties of these data. We have a file collections of these all data, like this is the one student. Then we have 2, 3, 4, 5 and 6 and up to 1000 and 10,000 students record. So you will make the file of that data. Beside that, why we need data structure in the programming? Because the data structure is searching the large amount of data. Data structure is speed up the programming processing. And the data structure is handle multiple and simultaneously requests. Let's just see the data structure philosophy. I just told you that the data structure is a programming effort. That is, speed up your program. Data structure can consume low space and the data structure is less time consuming. That's why the data structure is a programming choice. As you can see here, this is our example that a person opening the bank account for a few minutes. After a few seconds, he will do the transaction and he will close the account over the night. This is a simple example of the data structures right here. A data structure is a physical implementation of an ADT, and each operation associated with the ADT is implemented by one or more subroutines in an implementation. Data structure is usually referred to the organization for the data in main memory, and a file structure is an organization for a data on peripheral storage such as a disk device. We have the logical and the physical forms in the data structures. Data items have both a logical and the physical forms. The logical forms are the definition of the data items within an ADT. For example, the integer and the mathematical signs like plus and minus. Physical forms are the implementations of the data items within the data structure. For example, 16 divided by 32 bits integer or overflow. We have the example of the stack. We studied stack in a few minutes ago, but there are no such descriptions right there. We have the stack right here. Stack is just like this one. Stack is a linear data structure in which the element can be added or removed only from the one end, which is called the top of the stack. If you want to insert any of the value into the stack, so you can call it the push operation. And if you want to delete any of the value from the stack or remove any of the value from the stack, you can call it the pop operation. Stack is a LIFO concept, which is last in and first out. Hope so you understand now. Let's just turn to the queue. Queue is a yet another linear data structure which is used for the data structure in which the elements are added at one end, which is called rear. Let's just make a queue. This is called the queue where you can add the element, so it is called rear. And if you want to delete the element, so this is called front. So the front in the queue, you can delete the element, or you can call in queue and dequeue. The concept of the queue is FIFO concept, which is first in and first out. Let's just see the real life example that a person who is entering the queue first will out the queue first. Hope so you understand now with this example. There are some implementations of the queue. Let's just see, you are adding the value into the front like 20, 5, 12 and 17. So if you want to delete any of the value, so you can move like this one, or if you want to add any of the values with the help of rear, so you can add like this. Like here I just want to add 18, then 19, then 20 again, then 21, then 23. If you want to delete the value, so you can move like this one, like first one is a 20, then 5, then 12, then 17, then 18, then 19, and then 20, and then 21 and 23. You can move like this one. Okay, hope so you understand now with this example. If you find any of the problem regarding to the stack or a queue or a data structure in C++, please let me know, and thanks for watching this lecture. Welcome to this lecture. In this lecture we are going to talking about the stack data structure in C++. A stack is an abstract data type with a bounded or predefined capacity. It is a simple data structure that allows adding and removing elements in a particular order. Every time an element is added, it goes on the top of the stack, and the only element that can be removed is the element that is at the top of the stack, just like a pile of objects. As you can see here on your screen in the picture, this is, you can see we have the stack. At the top element, you can say that this is the top of the stack. If you want to add any of the element into the stack, this operation is called push operation. Or if you want to remove any elements from the stack, so this is called pop operations. A stack is an ordered list of similar data type. A stack concept is last in and first out. You can see here, this is the last in, and that will out when we just removing elements, so that will remove for the first. So this is simply the concept which is called LIFO, or you just say that this is FILO. So FILO means first in and last out. You can see this is first in and last out. 1, 2, 3, 4. So that will remove at the last. This push function is used to insert new element into the stack, and the pop function is used to remove an element from the stack. Both insertion and removal are allowed at only one end of the stack, what you just called the top. So you can only remove these elements from the top. A stack is said to be an overflow state when it is completed fully, and it's said to be the underflow state when it is completely empty. Let's just see, we have stack 1 right here and we have stack 2 right here. If this stack is completed, so we just say that this is overflow, and if this stack is empty, So this means that this is the underflow. The applications of the stack is, the simple application of the stack is to reverse a word. You push a given word to the stack like letter by letter and then pop letter from the stack. So there are other uses also for the application of the stacks are parsing and expressions conventions. So that will call the prefix, postfix, and you can say that yes, prefix and postfix, etc. Let's just see the implementations of the stack data structure. I just remove these all. So stack can easily implemented using the array or the linked list. Always are quick but the limited in size, and the linked list requires the overhead to allocate the link, unlink and delocate, but is not limited in size. Hence we will implement stack using the array. So we are see that we have stack number 1 right here, then stack number 2 right here, and then stack number 3 right here. Hope so you understand now. We have 3 types of stacks right here. Let's just see. Here I just create one another stack, and this stack is the empty stack right here. This is the top of the stack right here, and I want to add an element in the stack which is 6. So I just add this element with the help of this top of the stack. So now my 6 is added right here. So my stack is adding one value right here. Then I just want to add 7 right here. You can see I just add 7 right here. Firstly, I just define the stack of 4. Okay, this is a stack of 4 elements. Then I just add 2 and I just add 1. Okay, this is the simply insertion of 4 elements right here. If I want to add now 4 right here, you can see this element. So that stack will be overflow. After this one, that stack will be overflow right here. Okay, hope so you understand now. Or if you want to delete an element, so firstly 4 will remove, then 1, then 2, then 7 and then 6. Hope so you understand now with this example. In stack, all operations take place at the top of the stack. The push operation added an item to the top of the stack, and the pop operation is also removing the items from the top of the stack. Remember that. Now we see the algorithms of pushing the operation and popping the operation. First, it will check the stack is full or not. Let's just see we have the stack right here. So it will check that this stack is full or empty. So this is the empty stack right here. These algorithms work like this. If the stack is full, then print the error is you have the overflow stack, and that will exit the program. If the stack is not full, then increment the top and add the element. What is the algorithms of pop operation? It will check if the stack is empty or not. Then if the stack is empty, then that will print the error of underflow and exit the program like pop operations. If the stack is not empty, then that will print the value of the element at the top and decrement the top. Now we go to the coding example of stack data structure. Here we go to the code block, and now here I just write hash include and iostream. Close this code right here. So I just write this program for the stack, or this is simple implementations of the stack data structure with the help of object-oriented programming. Now here I just write using namespace std. Okay, Now I go to integer and main function right here. Now inside the main function, I just said that this is a stack and stack name is S1. Now I go right here and create the class name which is stack. So this is a simple representation of the class. You can simply implement your class like this. So integer, which is on the top, and then here I just write public. So this is access specifier integer a, and this is the array. I just told you that you can implement the stack using the array. So this is a maximum size of 10, or you may say this stack is the maximum size of 10 right here. Now I just write that stack, call the stack right here, create a new function, and here I just write top, which is equal to -1. Okay, now after this I just declaring the functions right here. So here I just write void, and void is the push function right here, and I just pass the parameter to this function which is integer x. Now I just define this function right here which is s1 dot push, and the push size here is 10 also, because we have the 10 digit stack here, or we have the 10 elements stack here. Now I just write that this is integer pop. Okay, and void is empty, or I just said that this is void is empty. So our this function, or this class for stack is completed right here. Now I just go to the main function, and here I just write that s1 dot push, and push 100 values right here. Now we go back to our function, and here I just create a module, or you may say I just create a functions to insert the data into the stack. Now void stack push, which is integer x. So first of all I just pushing the values right here which is integer x, and now I just write that if top, which is greater than or equal to 10, then cout, which is print that stack is overflow, and print the single line break right here. I just set the else statement right here which is a, and then increment operator right here which is equal to x. So you just simply write the increment statement before or after the top. Okay, it's up to you. So cout, which is here I just write element inserted, which is /n. Okay, hope so you understand now. So what is exactly the mean here, which is the stack push and integer x? As you can see here I just take a function which is for inserting the data into the stack. Firstly, it will check that this stack is overflow. So simply it will give you the message, means if we have the already 10 elements inside the stack, so it will show us this error. If this stack is not overflow, so that will go to the inserting the elements right here. Now go through another function. Now here firstly I just create the functions to insert the data. Now I just create a functions to remove the data from the top of the stack, because we are just removing or adding the data from the top of the stack. Now stack, which is pop, and then here I just write if top which is less than 0, and here I just write that cout which is stack underflow /n. Close this code right here and return which is 0. Now I just go to the else statement, and the else statement here is integer d which is equal to a, and this is the top minus minus, and that will return d right here. Okay, so I just simply create a functions to removing the data from this stack. Now here I just create void stack again. This is our function name right here to check that function of the stack is empty or not. Here I just write is empty, and then here I just write that if top which is less than 0, so see out that this stack is empty, and here is write /n for the single line break, close this with the semicolon. Okay, now show. Now after that we go to the else statement, and if this stack is empty, so that will print this statement, and if this stack is not empty, so that will go to the another statement which is cout, and that will set that stack is not empty which is /n, and close this code right here. So here if you want to perform any of the actions, so you want to add, so simply add it right here. But here we have created the functionality of these all, so let's just check. So we have an error, I just forget to add the semicolon right here, and yes, my program is running right here. As you can see here, firstly I just simply insert the libraries. You can see my program is running right here which is element inserted. Firstly I just create the class of stack right here. You can see first I just define integer top, public all the things like all the variables, integer a, and then I just take a functions right here, so this function is stack, and then write that top which is -1, so this one. Okay, so now after that I just add that push integer x and then pop and then element. So I just simply create these three functions right here. Then after that I just remove this. Then after that I just create another function name which is stack for push. You can see here, and then if the top is greater than 10, so that will simply show us the message which is stack is overflow. Then element, if this statement is not true, and then that will go to then this statement which is element is inserted. Then we create for deleting the elements from this stack, and at the last I just said that this function is for emptying the stack, and I just call these all functions right here in the main body. So let's just close this program, and now we will run it again. So you can see here all elements are inserted right here, and your program is working correctly. Hope so you understand now with this stack example. If you not, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the Q data structure in C++. Q is also an abstract data type or a linear data structure. just like a stack data structure in which the first element is inserted from the end, which is called rear, and this is also called the tail, and the removal of the existing elements takes a place from other end, which is called front, and you may say also this is the head. The concept of head and tail, which is used in queue and stack. So this makes queue as first in and first out in the data structure, which means that the element inserted first will be removed first. Like if you add the first element right here, so that will remove the first element, simply like the queue. I will show you the diagram of this stack and the queue right here. Like here you can see if you want to adding the element from here or if you want to adding the element from here. So like here if you want to add the element, so this is called front. Okay, sorry, this is called rear if you want to add the any elements from this one, or you may say this is also called the in queue operation. And if you want to delete the element from here, which is called the dequeue operation, so this is called front. So the front is also called head and this is called tail. Okay, hope so you understand now with this concept of the head and tail and the front and rear. Now this make, I just told you that this queue will make like FIFO concept, first in first out. If you want to add any of the element right here, from that will go like this one, or if you want to add any element from this one, so that will go like this one, first element, first in and first out, which is exactly how queue system works in real world. If you go to a ticket counter like to buy a movie ticket, and there are first in and you are the first in the queue, then you will be the first one who will get the ticket first, right? Same in the case like queue data structure. Data is inserted first and that will leave the queue first. This process is to add element into the queue is called in queuing. You can see this is called in queuing. And the process of removal the element from the queue is called dequeuing. In stack, you can add elements from here and you can add elements from here. It's up to you. Okay, hope so you understand now. Let's see the basic feature of this queue, that how this queue is work. First of all, I just told you that like stack queue is also an order list of the element of the similar data types. And queue is a FIFO concept, first in and first out in the data structure. Once a new element inserted into the queue, all the element inserted before the new element in the queue must be removed. To remove this new element, you just simply execute the first elements. Here in stack we use peek function is often we use peek function, which is often to return the value of the first element without dequeuing it. Hope so you understand the concept of the queue. I just remove these all and let's just turn to the coding example. Here we have hash include and iostream. Then I start that using namespace std. So now here you can see I just create stack 1, stack 2, sorry, q1, q2, q3 and q4. Okay, or I just remove these two queues right here, and here I just said that this is queue number 3 and this is queue number 4. Okay, I just divide this queue like this one, and 1 2 3 4, and this is also 1 2 3 and 4, 1 2 3 and 4. Okay, and 4. So this is our head and this is also our tail. So I just represent H for head and T for tail. This is the indexing 0, 1, 2, 3, 4. Same is the case like these all. If you want any of the element like this, simply I just said that this value is 2 right here, what I just want to add. It will go to the index 2, then add the next step, like here I just want to add the 2, then in the next step I just want to add 19 right here, 17 right here, or you just want to add 8 right here. So we have 1, 2, 3, 4, means 0 to 3 index right here, and I just add these all elements on this elements here. Now we have the head right here. Head is the front, okay? And if you want to add any element in the next index, so simply you just want right here. Now how we are just removing the elements from the stack? Simply you just add, like here I just add 10 right here. So simply when I just removing, so simply 2, 19, 17, 8 and 10 will be executed. Like this, I just want to remove the element 2 right here. Okay, so I just remove this 2. So the stack will be 19, 17, 8 and 10. Or if I want to remove the element 19, so this stack will be 17, 8 and 10. So like this one. Hope so you understand now with this concept of removing and adding the elements from the queue. Now we just turn to the coding example again. Here you see I just define the size, this is the size of 10 right here, and then I just write that this is a class of q, and then here I just write integer a, which is the array of size. Okay, and close this code like this one. Now integer, I just define rear for same like tail, and integer front, which is same like head. So rear is using like for adding the element, and front is for deleting the element. Now I just write that public and then q. Okay, same like I just make a functions right here. In stack I just said that like top, which is plus plus, but here I just write rear, which is equal to front, and the front which is equal to -1. Simply removing the element, so I just said that -1 right here. Hope so you understand now. Now I just create a function which is a void function for in queue, which is in queue. Now integer x, I just create the parameters for this in queue functions. So this is simply the declaration of in queue. I just go to the integer main, and here I just define q, which is equal to q. Okay, now go back to the in queue functions right here, and here I just define that here I just define void in queue integer dq, and at the last void display. Okay, close this code body. My functions are created right here, and now right here, so here I just write void q function again, which is in queue, and here I just pass the parameters, which is integer x. So this function is simply to adding the element or adding the data into the queue, which is using as an in queue. Now I just write that if statement, which is front for adding the element, which is is equal to -1. Okay, then I just said that front, which is plus plus to adding the element, so it will add the element. Now if rear, and the rear which is equal to size, so simply minus the value of the size and print the value with the help of cout, which is q is full. Hope so you understand now. Now I just define that else, and the else here is a adding the increment operator, which is rear, and the rear which is equal to x. Now our this function for adding the element is completing right here. Now we simply go to remove the element. Okay, here I just said that integer q, and which is equal to dq. Now return is a, and this is the plus plus operator, which is front, and close this code right here. So this follow the approach B. I just told you that this follow the approach B, which is like there is no such overheated, but whatever we move had one position to another position, after removal of the element, the size on the queue is reduced by on space each time. Remember that this is our B approach, and our A approach is there is no overhead of shifting the element one positions toward every time we remove the first element. Remember that these are the two approaches in the queue. So our this approach is working like here. Now I just remove this, and then here I just write void q. So this is the capital Q right here. So let's just see, we have, yes, small q, no problem. Now I just write here q for display the element. So this function is to simply display element, and here I just write integer I for loop, which I is equal to front, then I which is less than or equal to rear, and at the last I plus plus, and close this code right here. Simply the approach of cout, which is a, and a will print the array of I right here, and at the last I just write that end line. Okay, so after this I just adding one curly bracket right here. Now we go to the main body, and here I just write q dot inq, which is which is 10. Okay, so this is the size of 10, which is q in q. Paste it again. We are just writing 100 right here, then 1000 right here, then 1001 right here, 1002 right here. Then I just write that dq the value. Okay, this is a simple adding the values into the queue and then dq the value. Okay, then I just write in queue, which is 1003. Then I just said that dq the value 2 times, and then here I just write that in queue the value which is 104, and now here I just write queue dot display and close this code here. Now return 0. Now check the output, and we have an error here which is DQ, which is DQ and DQ, and yes, okay. Run it again. So you can see here after running this program that will show us the result of this program, that how we are working with InQ and DQ operators. So you can see here after this I just explain like this one. We have 1, 2, 3, 4, 5, 6, 7 elements. What I just add in the queue. First I just add 10. I just write that I just add 10 right here, or remove this, and here I just add 10. Then I just add 100. Then I just add 1000. Then I just add 1001. Then 1002. Then 1003, and at the last 1004. 0, 1, 2, 3, 4, 5 and 6. Okay, after adding 1, 2, 3 up to 4 indexing, I just set to the queue that DQ the value. So that will simply DQ the value here. So it will DQ 10. So we have the left values which is 100, 1000, 1001, 1002, 1003, and at the last 1004. Then I just set this 2 times DQ the value. So it will 2 times DQ the value and remove 110 from here. Then it will print 101, so 1001, 1002, 1003 and 1004, and I just set to the queue, please display the value right here. So it will display us these false values here. Hope so you understand now with these approaches of the queue. If you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture.